Welcome to JavaScript for web designers. The web designer's job is to use all the tools at our disposal to make the best, most engaging, and usable websites and apps we can manage. By making JavaScript a key part of our toolboxes, the palette of experiences we can create online becomes almost limitless. JavaScript is the programming language of the web, and becoming comfortable with it will allow you to do things with your websites that you just couldn't do otherwise. In this course, I'll introduce you to the basics of working with JavaScript, both in a browser and text editor. I'll also introduce you to some of the terminology you'll need to understand what's going on. Then, I'll show you how to use JavaScript to work with a shopping cart, responding to users' choices, checking for errors, and making a calculation. Next, we'll look at how to work with time, enhancing an event page with a live calendar and clock. We'll make use of the Bing Maps API, and you'll see how easy it is to add interactive content to a website using the power of an external service. And finally, we'll use JavaScript to interact with a small, RESTful API to solve a small but genuine pain point many people experience filling out web forms. As a web designer, you might not have written much of your own JavaScript. Maybe it's even seemed a little intimidating in the past. Working through these examples, you'll start to see that working with JavaScript in modern web browsers can be quite painless, maybe even enjoyable. Let's get started. Let's talk about what you should know going into this course. This is JavaScript for web designers, so I assume you are at least somewhat active as a web designer, and therefore that you're familiar with both HTML and CSS. I assume you've built pages with both these technologies and have a good understanding of how they work. I also assume that you would recognize JavaScript in a document if you saw it. You don't have to have used it before, but just recognize what it is so that when we start looking at it, you'll know, yeah, okay, I've seen that before, that must be JavaScript. If you find what we're covering going over your head, you can check out my course, Learning the JavaScript Language, to get an introduction that will help you read and understand the language better. Generally speaking, anything that you might not know about JavaScript we'll try to fill in as we go. The exercise files for this course are broken down by chapter. There's a folder for each chapter that requires files, and a folder for each video within that chapter. On most chapters, we'll be working through one project, so there's a folder you can start with and use to follow along, named WIP for Work in Progress. There are also end folders for each video that match up with the state of the files at the end of each video. To follow along with Chapter 6, you'll need a web server, so you'll be copying or moving the whole exercise files to that server's folder when we get to that point. I have a special note for Windows users. Please make sure to decompress or extract the exercise file's zip archive before you try to run any of the examples in a browser. Windows makes it possible, if you just open this, to browse a zip archive without extracting the files first, which is really nifty when you're working with, say, one file at a time. But the examples in this course load lots of related files. So if you try to use the examples that way, you'll have very unhappy pages with broken links all over the place and very little working as it should. So please extract the files first. The way you do that is by clicking the button that says Extract up here in the toolbar, if you need to, and then clicking Extract All. You can also do it by right-clicking that zip archive right here on your desktop and choosing Extract All. You'll get to choose a location where the files should be saved once they're extracted, and when that's finished, you'll end up with an exercise files folder again, so we don't see that. And when that's finished, you'll end up with an exercise files folder, which you can open and browse through normally. From there, you'll be able to open any of the files in your browser or editor as appropriate and expect them to work just as they should. This course includes several videos called challenges. Challenges are quick activities that give you a hands-on opportunity to practice what you're learning. I'll start each challenge by describing your core objectives for the activity. And just like the rest of the examples, each challenge will have sample files, and I'll tell you where to find them. I'll also give you a rough estimate of how much time I expect the challenge to take. When you've completed a challenge, make sure to check the matching solution video. In each solution, I'll show you how I solved the challenge and give you some of my thinking along the way. Again, this is an opportunity for you to master what you've been learning. I think it's really fun and useful to compare solutions with someone else, and I hope you do as well. A couple notes on compatibility. In this course, we're working through examples that come from my work in the real world where we have to care about compatibility with older browsers, but I want to mention where we're drawing the line for the purpose of this course. First of all, Internet Explorer and other ancient, in internet terms, browsers. We're sticking with web standards in this course, and we're not going to lose sleep working around the weird behaviors of these older browsers. They're still out there, but as long as we enhance our pages with JavaScript and are careful about it, our sites will still be accessible, which is the important thing. So everything you see in this course will work in modern web browsers like Chrome, Firefox, Safari, Edge, and Internet Explorer 11. Every once in a while, I'll mention something about browser compatibility, but for the most part, it is no great concern for our discussions. Also, we're not going to be using ECMAScript 6 or ECMAScript 2015 in this course. We're getting closer all the time to being able to use these more modern JavaScript features, but that day has not yet arrived, so we're going to stick with ECMAScript 5 here, which works everywhere without issue. Finally, this won't be the first time I say this, we're not going to use JavaScript where we could use CSS. CSS is very well supported and does what it does efficiently and well. So our examples will focus more on what JavaScript is good at than on things where you could pick one or the other. First, the most obvious question in this entire course. What is JavaScript? Let's get one thing out of the way right away. JavaScript is not Java. JavaScript shares some similar syntax with Java and has some other superficial similarities for historical reasons, but they're very different under the hood. The internationally standardized name for the language is ECMAScript, though it's still widely known as JavaScript as well. The point is, JavaScript is its own programming language, entirely separate from Java. Let not the names confuse you. So, now that we know that JavaScript is not Java, what is it really? It's the programming language of the web, and arguably the most widely used programming language in the world. And when I say it's the programming language of the web, I mean that it's the language that you use to program the web, to make it do what you want. These days, JavaScript is most commonly used for what we call front-end development, or client-side development. That is, any kind of programming that happens in a web browser, as opposed to on a server. If the code is meant to control Chrome, Firefox, Safari, Edge, or any other browser, JavaScript is the language we're using. For web designers, the biggest draw of JavaScript is the creation of interactivity. That means that anytime you can click, drag, tap, swipe, anytime you can interact with something on a web page, generally speaking, that's going to involve JavaScript in some way. There are certain kinds of interactivity that don't require JavaScript, but in general, if you want a page to react to something the user does, JavaScript is what you want. Right now, JavaScript is essentially the most popular and widely available programming language. You'll see JavaScript used in server-side or back-end development, especially through Node.js. JavaScript is used to run databases like MongoDB and can even be used to automate Photoshop. It's available nearly everywhere and can do a lot. For our purposes in this course, we're focusing on JavaScript's ability to control websites, but just know that the skills you acquire by learning JavaScript are applicable in many other areas. We pretty much interact with JavaScript all the time, but you might not know exactly what pieces of interactivity JavaScript may be responsible for on the sites you visit. To get a better idea, let's take a look at a few websites, toggling JavaScript off and seeing what happens. We'll start with this one, 2 Trees Olive Oil. All of these sites are going to be fictitious brands that we use for demonstration purposes, but the websites are live on the internet. If we scroll down a little bit on this site, we can see that the logo kind of zips up into the sticky header, in and out. We have some drop-down menus here, a couple of buttons with their own little drop-down menus and some interactivity there. It's a nice looking site. Let's turn JavaScript off here in Safari. I'm using Safari because it makes it the easiest to turn JavaScript on and off. Here in the Safari preferences, under Security, I just have a simple checkbox here to enable JavaScript. I've turned it off. Let's reload the page. We can see that the drop-down menus still work, although there's no special trimmings here to show me that it's a drop-down menu. That account and that shopping cart icon are somehow gone. And if I scroll down the page, the sticky header is still sticky, but it doesn't have its background color, and the logo just kind of stays there. So JavaScript takes care of some things that I wouldn't necessarily have expected here. Some styling as well as some interactivity. Let's turn JavaScript back on. And I'll go to the Land and Hotel site. If I click this button, I smoothly scroll down to the next section. And all of this navigation will take me around on this website. Once I get into the guest rooms section, first note that when I start scrolling, all of these navigation elements update with my scrolling. And as I scroll, I have these sort of waypoints where a little piece of content is made to appear and disappear depending on where I am in my scrolling. I'm using the scroll wheel as I go down here, and you can see these all change. And let's note that they're full screen as well. If I keep scrolling down the page, I have this split screen kind of effect here. Okay, Once again, nice looking site. Let's see what happens with no JavaScript. Scroll all the way back up, turn it off, and reload. Okay, first of all, none of these scenes is filling the screen entirely. Notice that this navigation is no longer following me around. That said, if I click that arrow, I still go to where I'm supposed to go. Clicking those buttons in the navigation does take me to the sections where they're supposed to appear, and that content that was in each of these sections no longer animates, but it is displayed. So in my opinion, this is a pretty good example of progressive enhancement. The site still works fine, even with JavaScript unavailable. The only issue we have here is this split screen area, where we had side-by-side panels of content kind of collapses into a little mess here. Otherwise, we're in pretty good shape. Turn JavaScript back on. And one more example. Let's refresh this page. We have some drop-down menus, another cart area, and we have some bouncing effects here on all of these images. All these items are filling the screen here. All right, let's turn JavaScript off again and reload. This is interesting. All the same content appears, but it no longer fills the screen. And the bounce doesn't happen on hover anymore. It just happens initially when the page first loads, and that's it. So it's a little strange. The JavaScript is affecting presentation a little more than interactivity in some cases here. But that said, the site is still entirely accessible, even with JavaScript turned off. I can go to the shopping cart still, and I can still see how much stuff I have in the shopping cart, even with all that turned off. One thing to note about this site is that if I simulate being on a smaller screen by shrinking my window, there's a menu button here that doesn't work at all when JavaScript is disabled. I need to turn that back on for this menu to work. Reloading, turn that back on, and now I can see this menu. So that would be something to consider for progressive enhancement purposes. So now we've seen some JavaScript in action and really looked at what it's doing and not doing. Ideally, we'd like to enhance our sites with JavaScript, starting from a baseline of total accessibility to the greatest possible extent. Then we can add JavaScript on top of that for enhanced interactivity and the occasional feature. In these examples, we've seen some areas where that was working successfully and some where it wasn't. Keep this in mind as you're building your own sites. People might turn JavaScript off or simply not have access to it, and plan accordingly. Now let's take a look at what I call JavaScript anti-use cases. That is, situations where you don't necessarily need to use JavaScript, and indeed, perhaps you shouldn't. So first of all, if CSS can handle it, you probably don't need to use JavaScript. Like anytime you're working with visual changes involving the hover event, when your mouse cursor goes over something, or focus events, when keyboard focus gets onto an element on a page. You can act on those events with CSS by itself. You don't need JavaScript. Back in the old days, JavaScript was used for things like swapping out an image in reaction to a mouse over or hover event, rolling over menus, tooltips, various things like that. CSS can handle such things pretty well, so we generally don't need JavaScript in those situations. If we want to do various kinds of animation on our pages, CSS transitions and transforms offer a great deal of power without JavaScript. No serious coding necessary. Those are definitely worth exploring. JavaScript is still a good match for more advanced animation, and perhaps best of all, you can use them together. If there's a situation where you need to be able to click something and have it animate, you can use JavaScript in combination with CSS transitions to produce very smoothly performing animations that will work on pretty much any web platform. If you want to learn more about that sort of thing, check out the course CSS, Transitions, and Transforms. Also, HTML5 form controls can be used instead of the custom widgets we needed to use in the old days to get different kinds of elements in our forms, like range controls, sliders, different things like that. This is especially important on mobile platforms where, for example, form elements for telephone numbers or email addresses will be wired up to custom keyboards well suited to entering that kind of data. These are a few examples of times when JavaScript is not necessarily appropriate, and you can look at other modern technologies that will accomplish the same goals. JavaScript is a wonderful tool that can do a lot. In fact, these days, it seems like there's little you can't do with JavaScript, especially in the realm of web design. That being said, it can be argued that all this power has been weaponized, and it has implications for the rest of us. First are the security risks. JavaScript can be used to load data via AJAX or by manipulating tags that load data, like image tags, object tags, script tags, and so on. Attacks like this are called cross-site script attacks, since they inject JavaScript that's not part of the site into visitors' browsers. When website authors become careless and leave these vulnerabilities, the result can be anything from the website being defaced, site visitors having their personal information revealed or stolen, and more. You can find out more about cross-site scripting attacks in the course Programming Foundations Web Security. Next are performance issues. Many websites, especially larger commercial websites, include JavaScript to pull and display ads and tracking scripts to gather information on their visitors' behaviors and activities, some of which are quite invasive for our privacy. These scripts are often large and, of course, need to be downloaded, which takes valuable time. Include very many of them, and page load times start to balloon, resulting in slow, poor performance. Keeping JavaScript lean is vital for good performance and user experience. Beware of using lots of scripts. Your visitors' and customers' time and attention is very valuable. There's more information on optimizing websites for better performance in the courses Vanilla JavaScript, Web Performance Optimization APIs, and Learning Enterprise Web Application Performance, among others. The result of these kind of issues is that JavaScript can be blocked, sometimes entirely, often partially. Content blockers on mobile and desktop browsers can try to block advertising and tracking scripts from ever loading, and some will take more aggressive steps to try to protect user privacy. There are institutional firewalls that may block some or all of your JavaScript, and of course, some users may simply opt out, disabling JavaScript as a feature of their browsers. Not many in the grand scheme of things, but enough that you should be aware of it. All of this is to say, feel free to use JavaScript, but be attentive and judicious about it. Be especially careful when using JavaScript to display data users have entered, and when adding plugins or libraries so as not to slow your site down so much. And keep in mind that not all users will have JavaScript available or turned on. If you're going to spend any time working with JavaScript, or indeed any code whatsoever, it's essential that you have a good editor. Your choice of editor is going to be a very personal one, but I want to go over some features that might help you determine what makes a good one. The first thing a good editor does is make your code more readable. I'm looking at this JavaScript file from the exercise files in Visual Studio Code. Most decent editors these days offer syntax highlighting, which will show you different features of the language you're working with in different colors. So functions and other language keywords will be in blue in this case, strings will be in red, and so forth. Code folding is a really useful feature when you're working on long code files like this one. If I mouse over into the gutter here, I get these little arrows, and if I click one, it folds the code for me. This can reduce distractions. Makes it much easier to see what you're doing, especially when working on a long file. There's also function or symbol navigation. When you build up a huge library of stuff in a file, as you can see, this one's pretty long, having a navigator that can help you jump to different points is really great. In Visual Studio Code, I can use Command-T or Control-T on Windows and Linux to jump to functions defined in this file. So let's say I wanted to jump to formatter. I can see it already, but it takes my cursor right to it. If you have a folder with lots of JavaScript files, there's often key commands to find symbols and functions across all of them. Another feature of a great editor is that it makes your code more writable. By that, I mean things like block or brace balancing. When you're writing code, punctuation is very meaningful, especially things like curly braces, parentheses, that sort of thing. And block balancing helps you see where those blocks start and where they end. So if I turn off the code folding here, when I click a curly brace, the other one that goes with it is highlighted. There are extensions available in the Visual Studio Code extension marketplace that can enhance this even further, changing the colors of these, drawing lines in between them, basically almost any level of visual enhancement that you might need to be able to see where these go is available via an extension for this editor. Many editors also offer auto-typing, which can help manage code indentation by keeping your code more readable. So if I hit return right here, even though I didn't hit the tab key, my indentation matches what I already have. Also, if I type punctuation like quotation marks of various types, or braces, parentheses, Visual Studio Code automatically adds the pair, so I only have to type one of them. So we've seen what all of that looks like here in Visual Studio Code. Let's compare it to an editor that is not code aware. Here's the same file in TextEdit, which has no code awareness whatsoever. It's much harder to read, which would make me more error prone, and no one needs that. And actually writing code would be slower, and frankly, less enjoyable. This is work, but we shouldn't be miserable while we do it. I've been using Visual Studio Code here, which is free and available for macOS, Windows, and Linux. Some other fine options include Sublime Text, which is also available for all platforms, and it's a paid application but has a very generous free trial. WebStorm by JetBrains is also a commercial app available for all platforms with a nice trial. WebStorm is a full-on integrated development environment. In my own work as a developer, I use its sibling, PHPStorm, which is basically the same application with additional sophisticated support for PHP. But if you don't use PHP, WebStorm is cheaper and excellent. I also still use BBEdit, which is only available for macOS, and is now a freemium app. It has a powerful free mode that you can use forever, with a paid upgrade for some of its more advanced features. Please try one or more of these options. There are trials available for all of them, and some of them are free. See what works for you. Once you start working in JavaScript on any kind of regular basis, you're definitely going to want to have a good editor. Let's talk about the other essential tool when working with JavaScript on the web, your browser. We're going to talk about the intersection between browsers and their various developer tools. That is, the tools that help you see what's happening with JavaScript and other web technologies on the pages. The first thing I want to say is, for now, just pick one. I'm going to give you several options, but really, any web browser that you're using right now probably has some tools built in, and you can just use whatever you're comfortable with. As you progress and get into professional work, becoming at least passingly familiar with all of them will help you, but to start, one is fine. In this course, I'll be using Firefox a lot. It's available on every platform and has web developer tools built right in. Here in the Tools menu, there is a web developer item, and I can choose Toggle Tools to open them up. The key command for them is Command-Option-I on macOS or Control-Shift-I on Windows. I can toggle them on and off. There are also several pre-release versions of Firefox you can download if you're curious about what's coming next for this browser, both as a user and as a developer. Google Chrome is available for every platform as well and has excellent developer tools. Those are available in the View menu under Developer, Developer Tools. The key command is the same, Command-Option-I or Control-Shift-I. There's a developer version of Chrome which is called Chrome Canary. If you get really interested in JavaScript and want to keep up with the very latest features or see what's coming down the pipeline for future releases of Chrome in terms of its developer tools, you can get a hold of Chrome Canary and take a look. But generally speaking, for everyday work, regular Chrome is great. For Mac users, you have the Web Inspector built right into Safari. It takes a little bit of work to enable. What I need to do is open Safari's Preferences, and then in the Advanced tab, I need to show the Develop menu in the menu bar. Having done so, in this new Develop menu, I have the Web Inspector right here. That's what Safari calls its developer tools, the Web Inspector. The key command to open them is exactly the same as the others. The bleeding edge version of Safari is called the Safari Technology Preview, and this is a very nicely packaged way for you to see what's coming up in upcoming versions of Safari. It's actively developed, getting releases all the time. You have to have a relatively recent version of macOS to run it, but if you do, it's an available option. And then finally, if you're a Windows user on Edge or Internet Explorer, I hope not, but it's possible, the tools are either called the F12 Developer Tools or simply Developer Tools, so named because you can hit the F12 key on your keyboard to make them come up. In Edge, they also use the same standard keyboard shortcut most other Windows browsers use, Control-Shift-I. You can also find them in the Edge menu under More Tools, Developer Tools. Microsoft offers this Insiders channel where you can download a beta version of Edge. As of this recording, they're in the process of replacing the innards of Edge, basing it on Chromium just like Google Chrome. So this might have changed, but the developer tools are available in the same way in that new version as well. As you start to work with JavaScript, you're going to spend a lot of time looking in the JavaScript console for errors and other information. And all of these browsers offer some very rich tools for taking apart your web pages and figuring out how to work with them. I strongly recommend that you start to get familiar with the tools that are built into your favorite browser. Now we're going to look at the JavaScript console to see what it can do for us. It's a very handy tool for learning basic JavaScript in general, and with a debugger, can give you great insight into the code you're writing. But for now, we're just going to look at the console. I can open my developer tools using Command-Option-I or Control-Shift-I on Windows or Linux. If that opens the Web Inspector for you, you can switch it over to the console, just clicking the tab named Console. In Firefox, this is called the Web Console, not just the JavaScript console. I'm going to make this a little bigger. All right, let's see what we can do here. This console lets me execute JavaScript right in line. So if I type, for example, 4 plus 3, and hit return, I get the result, 7. I'm executing JavaScript. Along with being able to execute code, I can also inspect code here. There's a built-in object in JavaScript in web browsers called window. And if you type a period after any object, you can see all the properties that are available on that object. These will be different properties that will tell you things about that object or different functions you can execute on that object, like window.alert, which will just pop up an alert. It's blank because I didn't give it a message. Also, there's a global object called document. And if I type a period after that, I can see, once again, lots of tools available to play with here. I can also define variables here in the console. I could say var x equals 5. The returned data for an expression like this is undefined, but x is actually defined. So if I type x and I hit escape to dismiss that big pop-up, hit return again, I get back the value that I assigned, 5. I can also assign other variables with more complex things, like, let's say I create an object called my friend. To create an object, I'll just pass a set of empty curly braces, like this. Once again, I see undefined, but if I type my friend, I do get back that empty object that I created. Now I can start to set properties on my little object. I'll give my friend a name, call my friend Margaret, and if I type an up arrow, I can get the last line or the last block of code that I typed here in the console. So I hit up arrow, and now I'm going to set an age also. We'll say that Margaret is 37. And now if I look at my friend again and type a period, I can start to see all the properties that are available on any object, as well as the ones that I created myself, like name and age. All right, let's clear this with the trash can button. I can also declare functions here. It gets a little tricky when you're typing what are usually multi-line expressions, like defining functions, but we can give it a try here. Here's a function called talking dog, and I'm going to hit Shift while pressing the return key to get some line breaks here. And then I can use my keyboard to navigate into the body of this function. And let's use window.alert and make this dog say woof woof, like so. Now if I hit return, once again, I get undefined, but now this function is defined here as long as I don't refresh the browser. So if I just type out talking dog like this and hit return, I get back the definition of the function. Different developer tools will show you this information in different ways, but I can see that this is a function that I've defined. If I want to actually execute it or invoke it, I need to attach the parentheses to the end there, and now I get my alert that says woof woof. This all works fine for experimenting directly in the browser, but most of the time we'll be writing our code in actual pages. So let's try that and see how it works. I have a script file that goes with this page open in my editor. Here it is. If I want to interact with the console from a script file, I use the console functions. There's a couple that we'll look at now. One is console.log, where I can pass a message into the console. We'll look at a second one before we go look at the browser, which is console.error, which is very similar. We'll save this file, go back to the browser and refresh and see what happens. I'm going to open the tools up again with Command-Option-I and refresh. So here is the result of the console.log. It's just a plain message, unformatted. Console.error looks very different. There's some color here, and if I disclose this, I get what's called a stack trace that shows me what code was executed to get to this point where this error happened. In both cases, I can see the file where this log message or this error took place, and the line and column number in the text. One more thing about these functions. Along with just being able to pass a scalar value, we'd call it, I can pass in variables. So let me define a couple. Variable 1 will be the number 2, and variable 2 will be hello. In console.log, we will pass variable 1. And in the error message, we'll pass in variable 2. I'll save these and refresh. There we go. I can see the value of each one of these passed into the log or the error. These can also take multiple parameters. So if I wanted to pass both into the log, I can do it like this. And I can pass in a message that goes with them to help me figure out what exactly it is I'm looking at if I can't remember. Variable 1 and variable 2. And this works for log or error. Like this. I can pass in as many parameters as I want into either of these, and they'll be printed right there in the console. So I'll save that, come back and refresh. Variable 1 and variable 2 are 2 and hello, and variable 2 is hello. Now you've seen some of the basics on how you can use the JavaScript console to learn about JavaScript. As you become more comfortable writing JavaScript, please do check out my course, Learning JavaScript Debugging, to learn how to use the debugger that's also built into these developer tools. Learning how to use a debugger can really change one's life for the better. But for now, the console is a great tool, and you should check it out. As much as I, and all authors, would love to teach you everything possible, at a certain point you're going to be looking for other help, most likely online. You can, of course, search your favorite search engine, which will probably take you to Stack Overflow or the like, but here are some other places to look to help prevent frustration-related injuries to your head, furniture, or both. I quite like the JavaScript documentation that's available through the Mozilla Developer Network. It's my favorite place to look when I'm looking for just general JavaScript knowledge. It documents the entire language, every object, every function that's built in. There's also a lot of useful example code and compatibility information on what features are supported in which browsers. For more in-depth information on browser support for various features of JavaScript and other technologies, caniuse.com is a great clearinghouse. You can search for various features and get lots of information to help guide whether to use those features. In this course, we're fairly conservative with what we use, but as you learn more and want to start pushing the envelope a little bit more, this is a fine resource. It's also helpful if you run into a compatibility issue and are wondering why on earth something is misbehaving. Could be a browser bug. If you want to understand your browser's developer tools better, the browser makers all offer documentation of varying levels of quality to help you. Mozilla offers the Firefox developer tools documentation here. Chrome has their own DevTools documentation site, which is quite comprehensive. Apple offers this page for Safari developers. Not much here, but what there is here. And Microsoft has a whole suite of Microsoft Edge developer documentation. As of this recording, Microsoft is in the process of migrating the engine that drives Edge from their own Edge HTML to the same one that Google Chrome uses, Chromium. So you might see references to both versions in their documentation. And finally, if you have access to other developers in your life, talk with them. If you don't work somewhere with web developers, go to meetups, look for online Slack, Facebook, or other groups in your area. Talking with other developers is a fantastic way to learn. It can help get you past trouble much faster than toiling away by yourself. As with any piece of technology, JavaScript has a lot of jargon. We're not going to cover nearly all the jargon you'd need to become an expert in JavaScript in this course, but I do want to give you an overview of a lot of the basics that you'll need to make some sense of what we're doing here. We'll start out with data types. JavaScript is aware of a lot of different types of data. You have numbers, 1, 2, 3, all that sort of thing. Everybody knows what a number is. You have strings, which are a sequence of words or characters. There are booleans, which refer to something which is either true or false. And then we have data types that are collections of data. Objects are the big one in JavaScript. We have some built-in objects like window, which is called the global object when you're working in a browser. Basically, everything that's defined in JavaScript when you're working in a browser is somehow part of the global window object. Then we also have document, which is how you interface with the document object model, which is something we'll be talking about a little bit later, and a whole bunch more others. Objects more generally, the ones that you can create yourself, and the ones that are built in are said to have properties which are just pairs of keys or names and their values. Then we also have arrays, which are a type of data you see in a lot of different programming languages. In JavaScript, they're basically objects under the hood, treated a little different. You can still think of them like we do in other languages, though. They're basically a sequentially ordered list of items, and those items can be any of the other data types. JavaScript has variables. You may remember variables from a math class in your past, but JavaScript uses them as well. If we think of JavaScript as a language, like a spoken language, then you can think of variables kind of like the nouns. They're sort of like proper nouns. You take something, be it a number or a sentence or whatever, and you give it a name. That name is the variable. There are also operators, which, if we're keeping in the metaphor that we're going with of JavaScript as a spoken language, are like verbs. These are how you can take things and make changes to them. JavaScript has a whole bunch of these, and they can be all kinds of symbols. A few of them are plus, equals, double equals, exclamation point equals, and there are quite a few others. There's plus, which can be used for addition or for concatenating two strings together. That means combining them together. There's the equal sign, which is used to assign data to a variable. And then there's the double equal sign and exclamation point equals, which are used for doing logical tests to say, this is equal to this, or this is not equal to that other thing. Now we'll move on to functions. If we're stretching this linguistic metaphor to its absolute breaking point, you could sort of think of functions as JavaScript's paragraphs. They're also a data type in their own right, but they're a way to combine statements into single blocks that you can reuse. If a function is inside an object, it's called a method. Arguments is another piece of jargon in JavaScript and indeed in most programming languages. They're also called parameters. In this case, an argument is how we get data into a function for further processing. That's really it. Most often you'll see them as named arguments, which means that they're variables that are defined only in the context of that function, which we can then process. Another piece of jargon is control structures. These are how we do logical operations. That is to say, if we want to do something in some cases, but maybe not others, or we want to do something a certain number of times. Anything like that is called a control structure. So when we're talking about logical control structures, we have if, else, switch, things like that. If and else are usually used together, and then a switch statement is just another way of phrasing the same thing. Basically, it all means if certain conditions apply, do this. If other conditions apply, do that instead. And finally, if this other condition applies, do yet another thing. Then we also have the notion of loops. There are a couple of main types of loops you'll use in JavaScript. One is the for loop, which you'll see a lot, and then the while loop. I'm not going to go into too much detail on those right now, but just know that they're both ways to do something over and over again until you need to stop. So that's a look at some of the jargon that you're going to be exposed to in this course. If you're interested in learning more about JavaScript, or you just feel like you could use some more detail on any of these sort of jargony topics, you can check out my course, Learning the JavaScript Language. There is a lot of jargon in JavaScript when you're talking about just pure JavaScript, not necessarily related to a web browser. But when you start working with JavaScript in the most common context, on the web, there's an additional layer of jargon called the Document Object Model, or DOM. The DOM is your way of accessing the outline of a page. All the elements that you've written out in your HTML are collected up in the browser and laid out visually and programmatically. So the DOM is your programmatic interface that the browser provides you to access all that stuff through JavaScript. It's a collection of methods and properties that you can use to get into each of those elements. When you're working with CSS to style your pages, that is, when you're writing CSS selectors using IDs, classes, tag names, all that kind of stuff, you're also working with the document object model just through a different interface. The DOM provides a lot of JavaScript functions, or methods. One that you'll see a lot is called getElementById, which is a method included in the built-in global object called document. GetElementById works just like an ID selector in CSS, the one that starts with a pound, to retrieve a page element using its ID. There are many other methods you can use, like querySelector and querySelectorAll. GetElementById is the fastest of the three, but the other two are very fast as well and much more flexible because they use all of CSS syntax to make their selections, not just IDs. In addition, the document object model provides a lot of properties for the page elements it knows about. Some of the ones that we'll see in this course are value, which is used to get the value of text fields or other form elements. There's checked, which is the property of checkboxes and select boxes, which can tell you, and I know this might sound surprising, whether they're checked. There's also class name and ID, which are properties of pretty much any element that will refer to whatever classes are set on that element and what the ID is. Now, of course, this is all very much a simplification of everything there is to know about the document object model. If you want to learn more about this, check out the courses JavaScript, Enhancing the DOM, or the DOM in JavaScript, jQuery, AngularJS, and React. But this should be enough to help get you through the examples that we'll go over in this course. One more thing before we start working on projects. The question often comes up, should I learn JavaScript by itself, often called vanilla JavaScript, or should I use a framework or library? There are uncountably many JavaScript frameworks and libraries. The most popular ones as of this recording are probably React, Angular, jQuery, and Vue. And they all offer benefits and drawbacks that are worth discussing. Using a framework can make life much easier because there are few tasks or problems that someone else hasn't seen before, and if you find a framework that deals with that problem, you can get on with your own work more quickly. A framework may include ideas and cleverness that you wouldn't have thought of otherwise, so they can be great learning tools and help you avoid common problems before you face them. A good framework will probably have security features built in that you would otherwise have to implement yourself. On the other hand, JavaScript libraries are a major contributor to page bloat, especially if used incautiously. You can also run into the when you're a hammer, everything looks like a nail problem, where you use a library for more than is necessary, ending up using JavaScript way beyond progressive enhancement, sending your site's accessibility out the window. You may also encounter security risks. Popular software is usually well tested, but it has to be, because anything popular becomes a target. Vulnerabilities could exist in features of the library that many people don't use and could go unnoticed. With vanilla JavaScript, you will hopefully only write as much code as you need to accomplish a goal, which helps keep pages as lean as possible. Taking complete ownership of your code can be empowering, and, if you document your code well, can help you understand how everything works when you inevitably come back and revisit it later. And of course, having a solid grasp of vanilla JavaScript can only help you when you use a framework or library. My guidance is for every library or framework you want to use, consider what you're using it for. How much are you using it? How much of it are you using? Can you slim it down? Can you load it only on certain pages instead of on the whole site? As you gain more experience, you might switch to vanilla JavaScript or a lighter framework to accomplish those same goals. Over the next several videos, we're going to look at how to work with forms. I can't say it's glamorous, but it's very common and touches lots of different little ways of working with JavaScript. We have a little store page on H+ Sport here, where we're going to choose some products, where we want to ship them, and calculate how much we expect to pay. This is simplified from what you'd see on a real store's website, so we can keep our concerns relatively modest. This is the before state. My form elements work. I can select from different states here and choose my radio buttons and checkboxes and such. When I click this button, the page refreshes, and nothing has actually happened. Let's take a look at where we're going with this project. This is the after state. Once again, I can choose some items, choose a state, and then estimate my total. And now I have an actual calculation with a little bit of information about what I'm paying for shipping and the tax that I'm paying. Switching over here to Visual Studio Code, we can look at the HTML. This is a static version of a WordPress site, so there's lots of markup, lots of CSS, and a whole bunch of existing JavaScript. This kind of illustrates how an even relatively simple page can get pretty complicated when you look at the guts. Scrolling all the way down to the bottom of the file, here's a script tag that references our JavaScript file. If I hold down the Command key and click it, it opens it up for me. We're going to look at that a little later. Let's scroll up again to the HTML for the actual form that we're building that's special on this page and actually used in our project. This page has IDs and classes all over the place. This is important for CSS styling, but it's probably even more important for our purposes in JavaScript. If possible, having IDs like these on your elements is really helpful. If your CMS or templating system doesn't provide them for you, you can still make it work, but it takes some clever filtering or selection queries to actually get these elements when you need to work with them. Also note that I'm using the HTML5 number element for these quantity fields with a min attribute set. Over here in the browser, that means that the browser knows this is supposed to be a number, and I get these little arrows. I can also, in some browsers, hit the up and down arrow keys. In some browsers, if I were to try and type something that's not a number in here, that wouldn't be permitted. Firefox allows it. But I do get some other interactivity here that's helpful, just by setting that element type to number. Now let's look at the JavaScript file. My code is going to be inside this little construct, which is called an immediately invoked function expression. It's a JavaScript idiom where a function is created and then executed immediately. We do this because before ECMAScript 2015, the only way to keep variables from being accessible globally was to put them inside functions. So inside this expression, we're free to name our variables anything we want without fear of screwing up other JavaScript we're also including, which is really important when you have a lot of scripts. This line, use strict, is a special line that turns on JavaScript strict mode inside the function where it appears, to help us avoid making mistakes like accidentally creating global variables and so forth. You don't have to know what that means specifically, but basically it just helps us write better code with fewer mistakes, and that's always a good idea. One more thing to mention, if you're following along and using Visual Studio Code yourself, I've changed a few of its default settings and installed an extension that might be of interest to you. So I open up the settings. What I've changed is I've moved the sidebar location from the left to the right. I've turned off the minimap, which is here. This is checked by default. I've unchecked that. I've turned on word wrap. I'm just using the search field to find all these settings. So it's on now, defaults to off. And I've disabled the breadcrumbs in the editor, right here. I'll close the settings. Looking at the extensions, I've installed the Prettier Code Formatter extension. This can format my code for me with a command. To make things easier for myself, I'm going to turn on Format on Save now that I have this extension installed. Format on Save. This means that every time I save a JavaScript file, it will be run through the Prettier Code Formatter to make all my code nice and keep me consistent. Very handy. Now we've seen where we're starting and where we want to ultimately arrive. Let's get to work. In this first foray into actually using JavaScript on the page, we're going to start looking at how to get data out of and back into the text fields and select boxes on this page, two very basic types of form elements. Let's open the JavaScript console with Command-Option-I or Control-Shift-I on Windows. I'll scroll down and I'm going to start with this quantity field under basketball sneakers. I'll right-click and inspect the element, and I'm going to copy its ID. We're going to start by addressing these elements by ID, which is the fastest and easiest way to do this if you have IDs available. So what I want to use is the function inside the global document object called getElementById. And as I start typing it here in my developer tools, it's auto-completed for me. I can hit the right arrow to expand that out without having to type it all. I'm going to need some parentheses here to pass in the parameter, which is going to be a string with the ID. So now if I hit return, I get back that input element. If I hover over it with my mouse, it highlights which one I've selected, which is really handy. I can make sure that I've really got the right one. Let's set a value on this, clicking the up arrow a few times. And now if I use the up arrow here in the console, I can get that same expression back and add .value, so I'm inspecting the value property of this element. Hit return, and I get back the value. That lets me get the value. I can also set the value by assigning this a number. So let's set it to 3. And there we go. I set it in the console, it changes here, and I get that value back as my return value. This works great when I have an ID on the element, but there are other times where you might not have that available. So let's look at some other ways to get to this form value without having the ID on the element. The document object also has a property called forms. This will give you every form that's on the page. I can see that there are 3 of them, and in the Firefox developer tools, if I mouse over these, it highlights them for me. So I can see that inside this forms array, the one at the index 1 is the form I'm interested in. And so now what we can do is use document.forms sub1. And if I didn't have an ID, I can use the elements property of a form. This will give me all of the form controls that are inside there. I can address these by numeric index or by their names. If I wanted to do it this way, I can pass in a string, and look at this. I think this is kind of neat. It auto-completes the IDs for all available elements in here. So I'm looking at the text field, that's the quantity of basketballs. Hit return, and that gives me back that same field. And once again, I can get its value. But of course, I'm still playing with the IDs here. So as I mentioned, we can use the numeric index. I can see that this is at index 0, and that also works. If I were in a situation where my form elements had a name, but not an ID, I could select the form using document.getElementById or document forms, whatever you like. Let's use getElementById since this form does have an ID. We'll copy it out of here. And then I could use the form element name, whatever that is. If this were basketball quantity, or whatever that is, and I could get the value from there. Now, as it happens, this element doesn't have the name attribute set, so I can't use that. But it is available to you if your form elements do have that. Okay, I'm going to clear this out, and we'll look at the select boxes. Here's one for state. I'll inspect this, and it has the ID sstate. I'll use document.getElementById again and pass in sState. And just as before, I can check its value. Currently, it's empty. Now, the reason that it's empty, an empty string, and not the value that's displayed is because of how I've defined the options here in the select element. Each of these option elements has a displayed value, which is between the option tags, and then a value, which is what's going to be returned by your JavaScript functions. So when I have no selection, I really don't want to have to deal with this select default and just have something empty. But when I set it to California, use the up arrow, and return again, I get back CA. In modern browsers, this is a very easy way to get the value of a select box. You can use all the same pieces of the JavaScript DOM API that we used before to select those text fields, to select your select box, and then get its value using the value property. This works great in modern browsers. If for some reason you have to support older browsers, select boxes also have some other properties that might be interesting to you, like options. This will return an array of all the options that are available. And there's also a selected index property, which will give you the index of whichever option is currently selected. Using value is much easier and, generally speaking, very compatible now. So I'd go with that first. But these properties are also available if you need them. Now, we haven't written any saved code yet, but we're starting to understand how to retrieve data out of several types of form fields. We'll look at some more coming up. In this video, we're going to look at another pair of form input types, checkboxes and radio buttons. They're a little more complicated to deal with than text fields or select boxes because they can be on or off, but also carry a value the way other inputs do. Let's scroll down a little bit so we can see our radio buttons and checkboxes of interest. We'll start with the checkboxes. I'll check this one and inspect it. So I have a label field here, and then the little checkbox that goes with it appears before. So I'm going to copy its ID. And we'll switch back over to the JavaScript console and select it using document.getElementById. All right, let's look at its value first, the same way we did with the text fields. We come back with yes. Okay, let's turn it off and try that again. Same thing. Okay, so this is obviously not working the way we might expect at first. But the value attribute on this checkbox is set to yes. So if we're passing this off for some back-end processing, this C special gift will come through with the value of yes. But that doesn't tell us what we want to know from a JavaScript perspective. What we want to know is this box checked or not? And as it turns out, there's a property for that. It's called checked. So I'm going to hit an up arrow here and change this value to checked. And that returns true because this checkbox is checked. If I uncheck it, try it again, false. Great. So when we're concerning ourselves with checkboxes, we want to use this checked property, not the value. If we want to get all the checkboxes in this little group that are checked, I'm going to go and find a way to select this whole group. It has a class called special, so I'm going to use a different selector. I'm going to use query selector. I'm going to select that special group. There it is. That will give me everything that's inside that div tag. And subsequently inside that, I'm going to get all the checkboxes. Query selector uses CSS syntax, so I can use all the same syntax that I would use to style these elements in CSS. So I'm looking for all the inputs with an attribute of type, which is equal to checkbox, because that's, of course, how we create our checkboxes. And then I can add on the pseudo class of checked. I'll actually change this to query selector all to make sure that I return all of them, not just the first one. And there we go. Now I get a little node list, which is an array containing each of the checkboxes that are checked. If I turn one of them off, use an up arrow and come back, now I just get one. So there are different ways that you can address your checkboxes. You just want to make sure that you're always using the checked property to figure out which ones are checked and which ones are not. Now let's look at radio buttons. I'll clear this console first. Radio buttons are set up so that only one in any given group can be selected. And the way that they're grouped, if I inspect this, is by the name attribute on the inputs. In this case, it's r_method. Radio buttons also use the checked property to tell you which one is selected. But it's not enough with radio buttons. You need to know what the value is also, because they all share the same ID. So we're going to use query selector to figure out which one of these in this group is the one that's checked. This is a little longer. We'll go with document query selector. And what we're looking for is the input whose name is r_method. Just paste that back in, which is checked. There it is. This returns the input, and now we need to get its value. So we can use the same syntax and get its value property. USPS for the US mail. If I change this to UPS, up arrow, hit return again, get UPS. And finally, if someone's picking up their order, we get pickup. We can also set all these different values. In this case, if I want to set which one of these is checked using JavaScript, I need to go back and get the ID to make this easy on myself. So I'm going to tell it to set UPS, say. r-method UPS. So I'll use document.getElementById, and I'm going to set the checked property to true. Fortunately, the browser handles turning the other one off for me automatically. And the same thing works on checkboxes. I'll sign up for the mailing list. We'll turn this one on. And there it is. Radio buttons and checkboxes have this checked property which tells us if they're on and off, and they can also hold a value. Just remember that with checkboxes, we need to look at that checked property, and for radio buttons, we need to find out first which one is checked, and then pull its value. To create interactivity, we act on events. It's time to start looking at events, how we listen for them, and subsequently take action. When a user interacts with something on a page, one or more events are fired. Clicking a button will trigger a click event and an input event. Making a selection on a select box will fire an event called change and also an input event. Some events fire without obvious user interaction. Like when a video is playing, you'll get an event called time update that says how much time has elapsed in the playback of that video. Basically, there are lots and lots of events available in the browser. When we submit this form by clicking this estimate total button, the page reloads with some URL parameters added on here. We don't want to do that. We want JavaScript to take over control of this form, which means we need to listen to an event on that form, specifically the submit event. Let's switch over to our code and start doing that. Here I am in my script.js file, which is in my work in progress folder for this project. To listen for an event, I need to add an event listener. There's a built-in function called add event listener, and I need to do this on an element. So I'm going to use document.getElementById and select which element on the page I want to listen to. Switching back to Firefox, I'm going to inspect this form. I'm going to get its ID. I'll just copy that. And now I'm going to add this event listener. This is a function which takes a couple of parameters. The first one is the type of event that I want to listen for. I type my quotes, and Visual Studio Code is attempting to complete this for me. As you can see, I have lots of different options here. I want to listen for submit. The second parameter is going to be some callable thing. You'll usually see these defined either as a function expression right in this definition, or as a reference to a function statement defined elsewhere. You might even see it as a string referring to a function. I'm going to use the function statement version. I'm going to call this estimate total, since that's what it's eventually going to be doing. Of course, it's not defined yet, so I need to do that. I'll create a function expression down here called estimate total. And event listeners can take a parameter which represents the event. You can name this anything you want. You'll often see it as just E or EVT. I'll spell it out as event for now. And inside this function, I have access to that event, and then I can do whatever I want in response to that event having been fired. So for example, I could log a message. You submitted the form. I'll save this. Prettier takes a pass at reformatting this for me. Everything looks nice. And we'll switch back to the browser and try it. I'll load up my console and clear out the messages. Refresh again. I'll click Estimate Total, and let's watch what happens. Well, if there was a message there, I didn't see it, because the page is still reloading. So I need to stop the page from reloading. I'll switch back to the browser, and here's how we do that. Almost every event has a method available called prevent default. This will prevent almost any default action that would happen when this event is triggered. In the case of a submit event, this would prevent the page from being reloaded and the form data being submitted to the server. So I'll save this again, switch back to the browser one more time and refresh. Clear these excess messages. I'll scroll down and submit this. There we go. Now the page does not reload, and I can see my message. One more note about the code here. I referred to this function expression by name here, but it's actually defined later. This code still works because JavaScript will transparently do what's called hoisting this function. So it's as if I wrote my code this way, where the function definition appears first. It works either way, and I kind of prefer to see my event handler first, then the function later, so I'll leave it like this. We'll stop there for the moment. We've brought the form under JavaScript's control by listening for and acting upon its submit event, and set ourselves up to add our business logic, coming soon. We aren't yet taking proper action to deal with the data in this form, so it's time to do that, starting with form validation, the term for code that inspects what data are in the form, validates that it's what we're expecting, and cleaning it up if needed. Here, we're going to start by making sure that the user has selected a state before they try to get their estimate. Switching back over to my code, I'm going to be taking this action inside my estimate total function. So I'm going to get rid of this console.log. We're going to replace it with something meaningful. I'm going to start by saving a reference to that state field that I'm going to be taking some actions on. So I'll say var state is document.getElementById, and we need the ID. Let's go back over to the browser and inspect this item. I will double-click to select its ID and then copy it. Close these tools again. I'll paste it in here. Okay, we've saved this. Now we can do something with it. The first thing I'm going to do is check its value. So we'll say if the state.value, this is how we get the value out of a select box, the easy way. And I'm going to check if it's empty, an empty string. We're using the triple equal sign here for the equality check. This is a little bit of a stylistic preference. The double equal equality operator is a little more permissive about what it considers equal. So I like to use the strict equality operator instead to make my intentions that much clearer. In any case, if the value is blank, and recall that when we have selected nothing, it doesn't come up as select, it comes up as an empty string because that's what we've set as the value on that option. When it's blank, we're going to show an alert. And that alert will say, please choose your shipping state. We could express this as window.alert as well. Because window is the global object from which everything in the JavaScript DOM API derives, that part's kind of assumed and we can leave it off for now. So we'll show an alert and then return from this estimate total function, indicating that we just want to stop here. Okay, I will save that. Prettier takes a pass at reformatting it. We'll go back and refresh. We'll estimate the total, and there we go. Please choose your shipping state. And if I select something, anything at all, I click the button and nothing happens. Great. That is actually what we're expecting right now. One more thing I'd like to do is give the user a little bit of a hint about what they're supposed to do when this value is blank. Ideally, what I'd like to do is put keyboard focus on the state select box. And the way we do that is to, instead of listening for an event, we want to trigger the event. And to trigger the event, we'll use one of the methods that's available on this element. On the state element, we have a focus method. When we call this, it triggers the focus event so that keyboard focus will appear on that item. I'll save again. We'll come back here and refresh. The previous value stays selected, and of course, if I click estimate total, nothing happens. But if we make this blank, I'll click elsewhere to make sure there's no keyboard focus on there right now. You know, nothing up my sleeve and all that. Click estimate total. Now I get my alert. and keyboard focus is placed on that item for me. Great. You'll be doing a lot of this, confirming that the user has entered something, anything at all. When you start getting into validating for specific types of data and whether it conforms to your expectations, you might want to explore something called regular expressions, which are a powerful way to express pattern matches, like, is this data alphanumeric? Does it start with a word it's supposed to start with? That sort of thing. It's out of scope for us right now, but I want you to be aware of regular expressions as a topic for future exploration with regard to form validation. So again, checking values on the form and informing the user of those errors and other issues is called form validation. We're not going to go too much more deeply into this in this course, but if you want to know more, check out the course Validating and Processing Forms with JavaScript and PHP. We're going to take things up a notch now, still enforcing the same requirement that the state field be filled in, but our approach will be more forceful. We're going to disable the Estimate Total button when the page loads and enable it again once a selection is made. To do this, we're going to listen to a different event, an event called DOM content loaded. We're going to listen for this on the document itself. So we're going to call document.add event listener, and the event we're going to listen for is DOM content loaded. This is the event that's called when the page has loaded sufficiently that the DOM is ready for us. The images might not have loaded. If we want that, we'd generally be using the load event. But DOM content loaded is what we can listen for when we just want to make sure that our form elements are ready for us to start adding event listeners to them and so forth. And for this, I'm going to just use an anonymous function that I can use to wrap a whole bunch of other code. So in here, I'm going to copy in my submit event listener. I'll leave my estimate total function defined down here. And now I'm going to start taking my actions on that estimate button. First, I'll save a reference to it, call it button estimate. We'll use document.getElementById. We'll pull its ID from the browser here. So I will scroll down here and inspect the element and pull its ID here in the developer tools. Now switching back to my code, I'll paste in that ID. So I have a reference to this button now, and I need to do some things here. When the page first loads, that state field is always going to be empty. So right away, I can disable that button. I'm going to use the disabled property, which is part of every button element. I'm going to just set it to true. This works just like checked on a checkbox. So when it first loads, that will be disabled. We'll save this and switch back to Firefox, reload, and try it. And there we go. Now I'm setting this at the JavaScript level instead of in the HTML because I'd want this button to still work if JavaScript were not available. Because presumably the way this store would work is I should still be able to submit this and maybe have the server do some processing and give me back an answer if JavaScript can't do it. So I'll let JavaScript take care of it in the course of all this other action here. Next, I need to add another event listener to that state select box. So I'm going to add another event listener. And what I want to do is check every time the value of that state box changes. So I'm going to use the event called change. Once again, I'll pass in an anonymous function here. And inside this function, I'm going to see what the current value of state is, just like I did down here. So I'll actually copy this little block, bring it up here. And this time, if the value of state is empty, I'm not going to spawn an alert. I'm going to disable that button. So I'll copy this line as well. Copy and paste this here. And if there is a value selected, I want to make sure that the button is no longer disabled. So I will set disabled to false. And I will save this. And now I should note that I originally saved the value for the state button down here in this estimate total function, which means that no other functions other than this one can see this value. So I'm going to cut this, take it out of this function, and put it up here just inside my DOM content loaded function. So I know it will be available once the DOM is ready. And because of where that's defined, I need to move my estimate total function into the scope of this handler as well. Now I can save that, and I think we're good to go. We'll switch back to Firefox and reload. I'm actually going to trim off these URL parameters first. Reload. and we'll give it a shot. So I can see that this estimate total button is disabled. I get a little cursor hint from Firefox to that effect. And now as I change this value, the button is enabled again. On and off and on and off. So that's working great. Wrapping your code that needs the DOM to be ready in a DOM content loaded listener like this is generally going to work really well. But there's one small gotcha to be aware of. If you have tons of scripts loading on the page, DOM content loaded might already have fired and been caught by a different listener, so yours might get skipped. I have to admit, I haven't seen this myself, but the Mozilla documentation mentions it, so I feel obligated to pass it along to you. If you're using a framework like jQuery that offers its own version of this, it's called the ready function there, gotchas like this will be handled for you. This step is now finished. We've seen how to take action once the DOM is ready for us, and disabled the Estimate Total button when there's no state selected, turning it back on when a selection has been made. Now we're going to take a look at sanitizing user input, a process that helps prevent unexpected behavior and security problems. If you've been following along with your work in progress folder, we're going to need to copy in some code from the script file in the exercise files for this video. I have that version open here. I've fleshed out the estimate total function a little bit with some more functionality to give us a little bit of a boost. So I'm going to select this entire file and paste it in to my work in progress version. I'll save it. And now we can go over the changes. Down here in estimate total, we now are collecting the quantities of all of the items that are in the cart. I have all of those saved in variables. I'm collecting the shipping state and the shipping method using document.querySelector to pick out which of those radio buttons was checked and get its value. Then we're doing some calculations here, getting the total quantity of all the items that have been ordered, the shipping cost per item, which is not set to anything at the moment, and the total shipping cost, also not set to anything yet. We have a tax factor, which will be used to calculate the tax based on everything that's chosen, an estimate, which is going to be our final answer, and the total item price, which has these three prices for each type of item hard-coded, and then they're just multiplied by each individual quantity. If the shipping state is California, we're setting a tax factor of 1.075, so we can do some simple multiplication to get the amount plus tax. And then we have a switch statement here, which will set our shipping cost per item to whatever it's supposed to be based on the shipping method that was chosen. So for the US Postal Service, it's $2 per item. For UPS, it's $3 per item. And for pickup, which is the default, it's 0. And then we do some basic calculations down here. Our shipping cost is how many total items we're ordering multiplied by the shipping cost per item. And then our total estimate is the total price of all the items, which we set up here, multiplied by tax, and then adding the shipping cost on top of that. In other words, the shipping cost is not subject to the tax. And then finally, we're using document.getElementById on that estimate field and setting its value to our total estimate. We'll go back to the browser and see how the behavior has changed by refreshing. Add a couple of items to the cart here. We'll set Illinois, USPS, and estimate the total. This looks like a pretty reasonable answer based on everything we've seen here. But what we want to do is sanitize the data that the user has entered to make sure that absolutely no mistakes can be made. We're going to sanitize the numbers to make sure that they're not strings of numbers, but actual numbers first. And the way we're going to do that, I'm going to show it in the console first here, is by using the built-in parseInt function. It looks like this. ParseInt, and then it can take two parameters. The first is whatever the piece of data is that you want to turn into an integer. So we're going to be changing strings of numbers into numbers. And to really use this most explicitly, you pass in a second parameter called a radix, which is the base of the number that you're using. Generally speaking, you're always going to use base 10, unless you're dealing with octal numbers or hexadecimal numbers. Pretty much always set it to 10, just to be explicit. And there you go, you get back 3. You can get all kinds of unexpected weirdness if you pass in things that are a little different, including not a number. But we do this to make sure that we are definitely getting a number based on what the user has put in. All right, let's try this in our code. I'm going to scroll up to where I'm setting the quantities of each item, these 3 variables right here. And I'm going to pass them through parseInt, each in turn. ParseInt, I'll copy this to each one. And I'll pass in that radix also. So this is going to convert each of those items into a number, no matter what actually appeared there. And for a little bit of further safety, I can tell JavaScript to convert this to a number, or if there's nothing in there to convert, or I get an answer that I don't like, set some kind of default value. This is a little trick using the alternation operator, also known as the logical OR. So this is either going to be a number, or I want it set to 0. So if this happened to be empty or not a number, like we saw in the JavaScript console, I would instead get 0. I'm going to put this in for each item's quantity. I'm going to do the same thing down here for my checkbox, because I want the shipping method to be an empty string, for sure, if none of the radio buttons is selected. So I'm going to save this and switch back to the browser to make sure that everything still seems to work. Refresh. I still have my quantities set here. Everything is selected just like it was before. Of course, when I reloaded the page, that set my estimate total to disabled, so let me just change this so it gets turned back on again. 330. So that's 90 times 3 is 270, plus 25 times 2 is 50. So that's 320, plus $2 times 10. Yep, okay, that checks out. All right, one more thing we want to do is format this number so it looks like currency. And for that, we're going to update our estimate. We're going to add a $sign to the front of it, so it's going to be a string, and then concatenate on the result of this calculation. So I'll wrap it in parentheses, and now I can pass that expression through another JavaScript method called toFixed. This will convert a number into a string with a certain number of decimal points. I'm going to ask it to show me 2 decimal points. So I've sanitized my data up here, and now I'm sort of massaging it to display it how I want to down here. We'll try this again. Reload. Set my state to New Hampshire and estimate my total. There we go. Now I get a nicely formatted number after I've chosen my estimate. This looks good. So now we've taken a look at sanitizing the user data to make sure that our calculations will always work exactly as we want them to. We use the alternation operator to get a default value. And finally, we set our estimated total using the toFixed method to make sure that this currency was formatted the way we wanted it to look. There's one more thing we'd like to do with this estimator. Show a little bit more of our work when we're making that estimate and displaying it. How many items were to be purchased, what the total shipping cost is, and what the tax rate is. This will be the first time we're modifying the content of the page directly, not just changing values or states in the form. So let's go back over to our editor and get started. I'm going to scroll down to where we calculate and display our final estimate. I'm going to set myself a couple of placeholders here. The total items, the total shipping cost, and the tax, just as a reminder. To start off, I'm going to get a reference to the place where these data will eventually be displayed. We'll call it the results. I'm going to use document.getElementById, and I need the ID, so let's go back over to Firefox. I'm going to right-click this general vicinity and hope that something good comes up. Well, I got the whole container, so I'll just keep disclosing these with the right arrow key after I click them. Here we go, results. That's what I want. I'll paste that in, so I have that ready to go. But how am I actually going to set the value? What part of the DOM API do I want to use? We'll go back to the browser and take a look. I'm going to open up my developer tools again and go to the console. There are 2 different ways that I can get or set the value of some region of the page: innerHTML and text content. Let's see how those differ. I'm going to address this little portion of the footer. I'm going to inspect this element to see what I have here. Okay, so this is footer widget 2, a class of footer widget 2. And it's inside this footer with an ID of colophon. So I'm going to use document.querySelector to retrieve this. I'll pass in that string colophon, and then that class was footer widget 2, I think. Mouse over that. Yes, got the right thing. Okay, let's see how these two items differ. I'll try innerHTML first. Hit return. Whoa, I get a whole bunch of stuff here. This is the HTML that produces this rendered as a string. We can compare that to the text content. Now this is just the text with all the HTML stripped out and leaving, as it happens, a bunch of the white space that HTML took up. So depending on how we want to do this, we could use either one of these to get or set HTML or plain text. We're probably going to be doing a little bit of formatting on this results area, so I think I'll be using innerHTML. So we'll close that and go back to our editor. So we're going to be setting the results innerHTML. And we'll start out by displaying the total items. We're going to just concatenate a string together here. And I believe, yes, I can rely on Visual Studio Code's autocomplete to help me here. The total quantity. And I'm going to concatenate on a little bit of HTML to help me format this. Just add a line break. And I'm going to do this a few more times. But if I just keep reassigning it, of course, I'm going to wipe out whatever I've done previously. So I need to do some concatenation here. I could write it like this. Results.innerHTML equals results.innerHTML plus, and then keep doing more stuff. But I like to shorten this by using the concatenation assignment operator, where I just kind of glom them together. So this next piece is going to be the total shipping cost. This is going to be displayed as currency. And so I think this variable was called, shipping cost. That's the total shipping cost, and we'll use toFixed. And we'll set that to 2 decimal places for a nice display. And keep that line break on the end there. We'll do this one more time for tax. And this tax is going to be displayed as a bit of a calculation here. So what I need to do is take my tax factor, which I set up for convenient multiplication up here. But I want to display it as a percentage. So first I'm going to need to take off that 1. We'll wrap these in parentheses just to avoid confusion. So that's going to leave me with just a decimal. And to display it as a percentage, I need to multiply it by 100. So we'll wrap this in another couple of parentheses, multiply it times 100, and then we'll bring that to fixed as well with 2 decimal places. We'll add a percent sign for display purposes here. And I also want to note which state is causing this tax factor to be used. So we're going to wrap that like this. We'll put the state in parentheses. So let me remove that. Add some more concatenation here. And then the other variable is, I can let autocomplete help me here, shipping state. Okay, that looks right. So to recap, we're taking that tax factor, trimming off the 1, multiplying it times 100, and then adding some decimal points for nice display. Adding the percentage sign, and then also displaying the shipping state. I'll save this, switch over to Firefox, and give it a try. Refresh. You get a couple of items into these fields. Set this to California. All right, let's see how we go. We have 3 items. That's what we're expecting. So our shipping cost should be $6. 3 total items, $6 shipping. Tax rate is 7.5%. We actually don't want that $sign here, so let me get rid of that. Get rid of the tax $sign. There we go. Refresh one more time. All the same inputs are still there. Estimate total. There. That looks nice. And with that, we've gotten our little estimator into pretty good shape. It calculates correctly, shows its work, and only tries to act when it has all the information it needs. Our JavaScript powers are growing. Now it's time for a challenge. We're going to respond to some changes for H+ Sport. For one thing, they've opened up a new store in Washington State. Yay for them, but we need to update our shipping estimator to account for the fact that they need to charge state sales tax for Washington, which is 6.5% for our purposes. Also, they're selling a new product, H+ Sport Mineral Water. It's fizzy. It also sells for $4 a bottle. We're going to need to update both the HTML and the JavaScript for this challenge. I recommend maintaining a similar HTML structure to what's already there, with classes and IDs, to make sure the styling stays consistent when you load it in the browser. You'll be adding a new tax factor and updating the calculations based on all that new stuff. This challenge should take about 5 or 10 minutes to complete. Good luck! Let's take a look at one possible solution to this challenge. We'll look at the page first. We can see we have all 4 products here. I'll increase the quantity of my fizzy water and add a couple other things. Down here under the state, I have several selections and my new one, Washington State. And selecting that still makes sure that the Estimate Total button is active. So I'll set UPS and click Estimate Total. This looks pretty reasonable. Let's set this to California. Yep, looks good. Slightly less tax for Washington than there is for California here. Great. So it seems to work. Let's look at how it was put together. Here in my index.html file, I'm going to use Command F or Control F on Windows or Linux to find the mineral water. Actually, I'm going to search for fizzy. There we go. That jumps me right to where I need to go. And I've followed the same structure of the HTML for the other products exactly, so it all gets laid out very nicely. Product name, little description, here's the price, and I set a unique ID both on the label field and on the number input, text Q water. Also added the state here to the select box with the abbreviation for Washington right here. And that's all we needed to do on this side. Let's take a look at the script now. So I'm going to scroll down to the estimate total function because this is where most of the action lies. Here's my item water variable, which is up here. I'm collecting the value of that field, running it through parseInt and making sure I set a default of 0, adding it to my calculation here with its price of 4, multiplied by the quantity. And now here, I'm checking the shipping state and adding an else if for Washington. I'm setting the tax factor to 1.065 instead of 1.075 to account for 6.5 versus 7.5% tax. And that's it. Everything else stays the same. For a little bit of extra credit I gave myself, I changed the behavior for how the estimate button is disabled. The way it was working before, button estimate.disabled was always being set to true when the page loaded. Now, because of the way browsers work, when you refresh the page, if nothing else changes, the values can be maintained for you. So always disabling this without first checking whether the state was actually chosen or not wasn't helpful. So instead, I broke out this logic that checks the state value and sets the disabled property accordingly into its own little helper function, which is called when that change event fires, but is also called right when the page is first loaded. So I get the same behavior used twice, but only defined in one place. And as a result, I have some better user experience here. And that's it. The challenge is done. Now we can move on to some other topics. In this next project, we're going to be working with date and time in JavaScript. This will let us create things like calendars, clocks, and do other functions on our pages that need to account for the date and time. We're looking here at the website for the Landon Hotel, a fictitious hotel with a website we've created for other courses. And they have an event calendar. So let's scroll down a little bit by clicking this button. That takes us down to this area, and if I click Events, that will jump me down to this Upcoming Events area with some upcoming events. Over here we have this Now region, which has nothing in it at the moment, but they'd like to have a clock so we can always see what time it is. Right-click this and inspect it so we can see how this is put together. So we have a div with an ID of clock. We have our label inside. And then we have this region, which is empty right now, with an ID of current time. There's a JavaScript file attached to this page that we can work with as well. Let's take a look at that. So far, there's nothing in here other than our boilerplate immediately invoked function expression and the switching on of strict mode. When the page first loads, we're going to want to set the time in that little region. Let's write a little code that will do that for us. So we know that when we want to do something when the page first loads, we're going to add an event listener for DOM content loaded, just as we did before. DOM content loaded. We need to handle that event somehow. So what we'll do is we'll retrieve a reference to that region where the time is going to go. I'll just name it something very short, C for current time. And we'll use document.getElementById. And we'll pass in the ID for this region, which I'll copy here out of the developer tools, paste it in. So now we have the region, we just need to put something in there. So we're going to set the inner HTML. I'm not totally sure if I'm going to need HTML for this or not, but I usually like to start with that and then change it to plain text if it turns out I'm not going to need HTML. So let's just hard code something in here just to make sure that it's going to work. We'll say it's 3 o'clock. I'll save that, get a little bit of automatic reformatting from Prettier. Then we'll switch back to Firefox and refresh. Okay, great. We're getting a time in here. It's not actually updating and it's not current. So we can fix that as well. Instead of setting this to a hard-coded time, we're going to need the real one. And to get the real time, we need to use a built-in JavaScript object called date. And the way we'll do that is by creating a variable. I'll call it d for date. And I'm going to invoke the date object's constructor. The built-in object is called date with a capital D like this. And I'm going to call new and invoke this object as a constructor, which is to say a function that's the same name as the built-in object. In this case, I'm going to call it with no arguments. When I call it this way, it gives me the time right now, and it gets that time from the machine where it's running. Specifically, in this case, from my web browser on my machine. So whatever time it is right now on my computer is what's going to be shown there. But having created this variable by itself doesn't actually do anything. I haven't changed the inner HTML yet. So far, in that variable d, I just have some kind of internal representation of what the date is in JavaScript terms. What I need to do is convert that into a readable time that I can use on the page. The simplest way to do that, and a good place for us to start, is by using a method on the date object called toTimeString. So I'm going to use my date object that I created, letter D. I'm going to call toTimeString, like this. So we've replaced that hard-coded time with this toTimeString. So I'll save this and we'll switch back to the browser, reload, and see what it looks like. Holy moly, that's really long, isn't it? Not exactly nicely formatted, but it is the real time. Now, I could do some formatting on this, lop off the time zone here, this offset, but I'd still have this in military time with seconds and all that. I don't know if we really need that right now. So coming up, we're going to explore some of the other methods that the date object offers that can give us something that will be a little more readable. This is a good starting point, though, and it's an easy way to make your page self-updating without any server-side interaction. Now we're going to look at some of the other methods that are available on the built-in date object so we can format our time a little more nicely than this. I'm going to open up the JavaScript console to experiment with this. So I'll hit Command-Option-I here, open up the console, clear these messages. First, I'm going to give myself a date object to play with. So I'm going to create this with a name of D, just like I had before, the new date. And this returns a date object. Now remember that we have the string version of this, so toTimeString. So if I wanted to start to do some reformatting of this, I could consider just trimming off everything that comes after that. So we could save this as a string, toTimeString, and then I could use the substring method and just take off everything up to, say, the 8th character. That would give me this, but it's still just a string. Instead of kind of twiddling around with this string, let's build a new one based on what we actually want to appear here. The date object has many, many methods for us to try. If I start to type this, almost all of these are going to start with get. You can see in the autocomplete list, there are a lot of them here. And if I start to type get, I limit things to only those functions that start that way. This being a clock, I'm going to want the hour and the minutes. So we have a method called getHours. Let's see what that does. Okay, I get 13, just like I saw here in the string. Likewise, there is a getMinutes function, which is going to give me the minutes. And of course, we have lots of other things like you might expect, like get the date and get the day. Now note that these are also returning numbers. Some of these we might expect, some of them we might not. We'll look at them in a little more detail a little later on. And then of course we have toTimeString, which we've already seen, and toDateString, which gives me a string just representing the date. So we have lots and lots of options here, but for our purposes with this clock, we just need the hour and the minutes. So let's update our code to account for what we actually want. First thing I will do is get the hours. So I'll set a variable for the hours, and we'll use getHours here on that date object. And then I'm also going to need the minutes. So we'll do this way. I'll set my hours and then concatenate on a little time separator. We'll use a colon. And then concatenate onto that the minutes. We'll just do that directly in line right here. I'll save that and we'll give it a try. Switch back to Firefox. I will close the developer tools and refresh. And there we go. This is a time. Now it's still formatted this way in the 24-hour version, and I'd like to do it as the 12-hour version. So I'll switch back to my code and do an operation here on my hours. Basically, if the hours are greater than 12, I'm going to want to take off 12 hours. So I will just say hours equals hours minus 12. That works. I could also rephrase this a little more succinctly by using the minus assignment operator here. Hours minus equals 12 is the same thing, just a little shorter. So I can save this and try this again. There we go, 1:32 in the afternoon. If you're thinking ahead here, you may be wondering what happens when the clock strikes midnight. That's another edge case that we'll be dealing with a little later on. But now we've seen some of the methods that are available on that date object to give us different components of the time and date. There are going to be instances where we'll need to reformat them even after we extract just the piece that we want, because the representation of that number in JavaScript may not be exactly what you want when you bring it into your page. But there are quite a few options and lots of flexibility. At this point, we have a clock that will be current when the page first loads. But what I'd really like is for the clock to stay current as long as I have the page open. That means I need some way to update it every, say, minute or so. In JavaScript, we use timers for this purpose. Let's see how they work. We have available a couple of different timer functions in JavaScript. One of them is called setTimeout. The other is called setInterval. If you've looked at other people's JavaScript code before, you may have seen one or the other of these. We'll start with setTimeout. SetTimeout is a function that takes two arguments. The first one is a function that we want to execute after a certain delay. And the second parameter is how long that delay should be. So let's create a function called updateTime. And we'll wrap all of this code to actually perform that update. So I'll cut all this and put it inside the body of this function. And we'll give this a delay of 2000. The second parameter is expressed as milliseconds. So that means that this function will fire 2 seconds after the page first loads. So let's save that and switch over to Firefox and try this again. Wait 2 seconds, and there we go. Now we have a current time. Now, if we wanted this to keep going, we'd have to just keep calling this over and over again, setting progressively larger and larger delays. That is obviously going to be inefficient and impractical. JavaScript has another timer function that's used for ongoing continuous updates. That one's called setInterval. We'll set this to updating every second. So I'll save this and switch back to my browser and refresh. Okay, I can sit here all I want and nothing's happening. Now we're pretty sure we're using the function correctly and that this is updating, but it's just getting the same answer every time, so it's staying the same. But we need some indication that something is continuously happening here. So let's update our code to give us something that will change every second. How about we add the seconds? So down here on our time string, I'll concatenate on another colon, and then we'll use D again, only this time we'll get the seconds. Date has that function available, so why not use it? We'll save and refresh. And here we have the seconds, but nothing's changing. So obviously we have a bug here. And the bug is that every time this function is called, we're always referring to the same date object that was created outside of the body of this function. So no matter when we call it, we're always just rechecking the same exact timestamp. To fix this, we need to bring this instantiation of the date object inside this function. So every time it's called, we will truly get a new date. Okay, save that again, go back and refresh. There. Now we have a time that is updating itself, and we'll just keep doing that as long as we have the page loaded. One other note I want to make about timers. This is one that we want to just keep going and keep going and keep going forever. If we wanted to be able to stop it at some point, these timer functions will return an ID. So we could call this clock ID. And if we wanted to stop it at some point later, we could call the function clear interval and pass it the ID that we got from its initial setting. We don't need that in this case, but it's something worth noting in case you have need to stop your timers at some point later. So again, we have this clock that's just going to go on and on forever. But this isn't actually the way I'd like to display this. I'd kind of like it to show up more like a digital clock. I'd kind of like it to look like the digital clocks that I'm used to, where I don't see the seconds, I just see the time separator flashing. Let's do that. So now instead of adding the seconds on, I need some way to make this time separator flash. So first we'll try it by making it display or not display. I basically want this to show up every other second. So in other words, maybe when the second number is even, display the colon. And when it's odd, hide it. So let's create a variable. We'll call this sep for the separator. And we'll start it off as a colon. And then we'll check the seconds on the date object. So if date.getSeconds, and we need some way to determine whether this number is even or odd. We can use the modulus operator for this, which is the percent sign. So here, what I'm saying is, if I take the number of seconds and divide it by 2, what's the remainder? If it's even, the remainder will be 0, and if it's odd, the remainder will be 1. So I'm defaulting to my time separator being a colon, but if the number of seconds is odd, I want to make it a space. Like this. Now I have my separator, I actually need to use it. So let's change out this hard-coded colon for our separator. I will save, and now we can go back to the browser and refresh. Here we go, let's try it. And there we go. We have a time that shows the hour, the minutes, and has a nicely flashing separator here. If you look very closely, you can see that these numbers are shifting around a little bit, left to right, as the time separator flashes. We'll fix that later, but this is a very good start. Let's finish tidying up this clock. I want to get rid of this little bit of side-to-side motion. Because we're using a 12-hour time display, I'd like to display the meridian, that is, whether it's AM or PM, and deal with any edge cases we can think of, like what happens during the midnight hour. We'll deal with the jumpiness first. Right now, I'm either displaying a colon or a space, and they're not the same width, so it kind of shifts things around a little bit. Instead, I think I'd like to always display this colon, but just make it transparent or white. Let's go back to our code and take care of that first. Here in Visual Studio Code, I have my separator right here. What we're going to do is we're going to wrap that in a class. So I'm going to create a variable for that class first, which will initially be set to nothing. This project includes a class called trans, short for transparent. And so now instead of making the separator into a space when the number of seconds is odd, we're going to change the class. So I'm going to bring this down here. I'll change this separator to separator class. And I'll cut this and bring it up here. Okay, that's part one. Part two will be to actually use that class on the separator. So I'm going to change my specification for my separator to include this class. We'll say that the class equals, and we'll use the separator class here. Okay, great. We'll save this and refresh. And there we go, not the slightest bit of movement. Rock solid. Okay, let's add the AM and PM now. I'm going to add another variable here. We'll call it AM PM. And we will set it initially to AM, like this. I'm going to display it down here. And actually, let's bring the minutes up into a variable as well, just for cleanliness and consistency. So I'm going to show the hour, then the separator, then the minutes, and then AM PM. And actually, I'll put a space in between them. There, that seems like it should work. Now, right now, this is always going to display AM. But when the hours go past 12, I want it to change to PM. So here, I will set AM PM equal to PM. Okay, that all looks pretty good to me. Just add a little more white space for readability. Great. Now I'm saved. We'll go back to the browser and take a look. Oh, hey, this is exciting. We'll have to deal with that next. We'll refresh that, and here we are, 2 o'clock p.m. So let's deal with this strange display of the minutes. Because the number of minutes is less than 10, it's just giving me the integer, and I'm just passing that right through without trying to format it nicely by adding a leading 0 in front of it. That's easy enough to fix. So we'll say if the number of minutes is less than 10, my minutes should be formatted as a string that starts with a 0. So I'll say minutes is a 0 plus whatever the current number of minutes is. We'll save that again. There we go, much better. There's one more thing to take care of here. When it's 1 o'clock in the morning, get hours gives us a 1. 2 o'clock in the morning, it's 2. But what happens at midnight? Well, in JavaScript, the number of hours is going to be 0, and we don't want 0 to display here. So we need to add a special case for handling that as well. We'll deal with that here in our little control structure that's dealing with the hours. So if the hours are greater than 12, we're handling that. Or, else if the number of hours is exactly 0, we will set hours to 12. So it will display as midnight with 12 instead of 0. We're not going to see that right now, but we know that that's something we'll run into later, and so we've added it to make sure it'll work. With all these changes made, our clock is looking and working very nice indeed. For this challenge, we're going to enhance the events calendar by showing the date as well as the time. It's much more useful when we're looking at the events to have the date and the time and show them both over here in our now box. I've hard-coded it as January 30th here. I'll right-click and inspect this so we can see. Here it is. The value of this is hard-coded to January 30th. This is the part that we'll be updating. So we'll call this challenge date and time. You're going to add the date to that now box and format it like June 16th. Remember that some of these functions that we use to get parts of dates and times will be numbers, and they won't necessarily be exactly in a format that we can use right away. So this is going to take some work to format it and spell it out like this. This is relatively easy to describe, but will certainly take at least a few minutes. Good luck. Let's walk through one possible solution to this challenge. First, we'll prove that it actually works. It is indeed December 5th at the moment. And this is the time which was working before and hasn't broken since then. What a relief. All right, let's take a look at the code. First of all, I'm storing a reference to that current date area using document.getElementById here. And then along with hours, minutes, and AM, PM, I'm getting the month and the date using getMonth and getDate. Now, the month that I get back from getMonth is a number, and I want to format it as a word. So I have a little helper function called formatMonth that we'll take a look at in a second that's going to handle that reformatting for me. And then down here, I'm using text content to change the contents of that current date area because I don't need to use HTML. So I just have the month followed by a space followed by the date. All right, next, let's take a look at this format month helper function. We have some sanitization up here first. I'm making sure that what I get is turned into a number using parseInt, as we've seen before. And then I'm making sure that the number that I'm getting is in the range that I want it to be, which is to say, I want to make sure it's somewhere between 0 and 11, which is what that function is supposed to return. Now, there are different ways that we could have actually transformed the number into the name. You could have used a switch statement like this, or an if-else series, eventually getting yourself whatever the name of the month is supposed to be. What I did here was I created an array of names. Arrays are zero indexed, just like the values that come back from that getMonth function. So it's a good match to use the two of them like this. So all I have to do is create that array of all those month names, and then I can return months sub m, which is that index that comes back from getMonth. That's returned and stored in this variable, and then displayed here. And there we have it, a little region of the page that tells us what now is. Working with dates like this involves a little bit of elbow grease to get things formatted just so, but once we're done, works great. If you felt like writing all that code to handle dates and times was maybe just slightly tedious, you are not alone. In the grand scheme of things, it wasn't a ton of code, but if you were working with dates and times a great deal, you would probably want something to help. We're going to look at a couple of third-party libraries that are very helpful for working with dates and times, and try using one of them. Probably the most popular library for dates and times in JavaScript is Moment.js. It can do almost anything you could possibly want, and just like it says here, it can parse, validate, manipulate, and display dates and times in JavaScript. It can deal with time zones for you, do almost anything you want. There's also another smaller library just called Date and Time. This is the one we'll be using in this example because it's much smaller and it's very focused, and it happens to do exactly what we need for this project. Both of these packages are also available on NPM, the Node Package Manager. It's a very handy utility that works on the command line for downloading and managing JavaScript packages. If you're working with third-party JavaScript packages, you would be well served to learn how to use it. Check out the course Learning NPM, the Node Package Manager, to get started with that. I've included Moment and Date and Time in the lib folder of the exercise files for this chapter, so you can easily try out either one. We're going to use Date and Time, as I said, because it's leaner and does exactly what we want. To use these libraries, we need to install them with their script tags. So I'm going to scroll all the way down to the bottom of this file. Here we go. This is our custom script file, so we need to add date and time before this. With the structure of our exercise files, this is going to be up a level and then into the lib folder. We're going to call date and time, and we can use either the minified version or the non-minified version. We'll use the non-minified version for now in case we want to read this, but if you were going into production, you'd want to use the minified version. The date and time library is so small that it doesn't include built-in support for Meridian time formats. There's a plugin for that you can install as well, which is also available here in the exercise files. Visual Studio Code is very helpful in completing the name of that for me. So I'm loading these in the correct order. First the library, then the plugin that handles that particular time format that I'm going to be interested in, and then my custom script file where I'm actually going to use that library. Okay, I can save this and move on to my actual script. Here's the code that we're going to be modifying. Let's take a look at the documentation for date and time and see what we're going to be using. The documentation appears here on NPM and on the GitHub page. Either one will be fine. So we'll scroll down. What we're looking for is a way to format our date in the way that we want it to display. And as luck would have it, the very first function is called format. We can see this takes a date object, and then there are a variety of formats here. We have the month in various formats, the day, the year, the meridian. We have an asterisk here reminding us that this is going to need to be in the plugin. Just about anything we could want here. So let's go back to our code and we're going to use what we're learning here. Pretty much all of this code up here is dealing with time formatting and date formatting. So we can get rid of all of it. All we need is our date object. And then we're also going to need to load the plugin. When we bring date and time into our project, that exposes a global object called date lowercase. And it has a method called plugin for loading its plugins. So we're going to load the Meridian plugin, or rather, we're going to tell date to use the plugin. It's already loaded by that script tag. We have our formatting for our time separator, and now this is where all the display actually happens. So we're going to be using the date format function. So this is date.format, and looking at the signature of the function here in its documentation again, the first parameter is the date object. So in our case, it's going to be D. They're calling it now in the docs. So we'll pass in D, and then the second parameter is the particular formatting that we want. So for the time, the first thing that we want is the 12-hour version of the hour. And here it is right here. You can get it with or without leading zeros. If we pass in just H as a string, like this, we will get the hour in a 12-hour format with no leading zero. Next, we're going to want the minutes. And for that, we have a couple of options here, with and without leading zeros. In this case, we do want the leading zeros for the minutes. So we'll use MM. And we could copy this and wipe out AM, PM like this. But because this whole thing is a formatting string, we can put everything in here. So what I want here is the minutes followed by the AM or PM. Referring back to the documentation, here's the Meridian. And I'm going to take the version with no periods, which is a double capital A. There we go. Likewise, I'm going to be able to get rid of everything here for the date, replace that with a date format. And to save us a few round trips back to the documentation, I'll just tell you that we want the full name of the month spelled out, which is 4 capital M's, and then a space, and the date, which is a capital D. I'll save that, and we no longer need this format month function either. Bye-bye. We've saved this. Now let's switch back to the browser and check it out. I reload, and I can see I have a double A here, so clearly something is not working here. Let's go back and check this. Oh yeah, I misspelled Meridian. Save that, switch back, and refresh one more time. There we go, that's what we want. For comparison's sake, here's the version that uses a library, and here's the previous version, where we wrote everything ourselves. This could be cut down a little bit with some different formatting, but it's still almost twice as much code. So you have to balance the trade-offs of including a library which has probably 16 kilobytes maybe of code just for a little bit of savings here, but it's a relatively small library and it could be worth the trade-off here. I usually think it is to use this small version of a date and time formatting library to get this kind of functionality. But depending on your project, you can make that decision for yourself. The point is, when we use that third-party library, our developer experience is much more pleasant, and it results in a good user experience as well. Working on the website for H+ Sport, I have their address here on their contact page, but it would be even nicer to show a map. Of course, there's an easy way to do this. We can select the address, copy it, and go over to Bing or Google Maps and search for it. Now, of course, this is not the actual location of H+ Sport. That's a business that doesn't really exist. This actual address is for the Capitol Records building. We'll just pretend this is where the business is located. So anyway, we can embed this map. This gives us a chance to generate some code, which I can then copy and bring over to my HTML file. I'm going to scroll down a whole bunch to my custom content here. Here we go. I'll paste this in right here. I'll save that, go back to my browser and take a look. Refresh this. And there we go. We have a map. This works fine, but I don't have a whole lot of control over how this map looks or what happens when a user interacts with it. To get that kind of flexibility, I need to take control of the map programmatically using an API. That is, a software toolkit provided through JavaScript that lets me change the maps. Let's talk a little more generally about what an API is and how you would use one. When I say API, I'm referring to an application programming interface. In this case, when I say application, that's the page or the app that I'm working on. And the API is the official way to use someone else's JavaScript use someone else's resources to create something on your own site. I find that one of the biggest challenges when working with an API, other than the challenges of programming in general, just fixing bugs and so forth, is the terminology. You may know what you want, but you won't necessarily know what it's called, because an API is written by a developer. So they might have to be very careful about how they name things to avoid collisions with other terminology and technology that their company works on. So they won't necessarily use the same terms you would when you're trying to solve any given problem. This is where example code and documentation is your friend. A well-written API usually includes good documentation and useful example code that you'll be able to copy and paste to get yourself started. Many websites and services offer JavaScript APIs. Bing, in other words Microsoft, offers a rich Maps API with a generous free tier, which is what we'll be using shortly. Of course, Google offers many JavaScript APIs, including Maps. Theirs is quite popular, but currently requires an associated billing profile and therefore a credit card to sign up, so that's not really a great match for us right now. YouTube offers APIs for controlling their players, as does Vimeo. SoundCloud also offers an API, but in their case, they call an API an SDK, or a software development kit. So when you're looking for an API or a way to interface with someone else's service using JavaScript, you can search for the service's name and then JavaScript API or JavaScript SDK and see what comes back. So that's what an API is, and going forward, we're going to see how the Bing Maps API works to add a map to our website that really works just how we want it to. Let's create our first map using JavaScript instead of this embed code down here. We're going to need a couple of things to do this. A Microsoft account, which you can get at live.com for free, and an API key, which you can get here at bingmapsportal.com. I'm already signed in using an Outlook account, and here under my account, I have my keys. So far, I don't have any keys, so it's prompting me to create one. We'll call this JavaScript for Web Designers example. This is going to be a basic key that I'm going to use for development and testing. You could choose that this is going to be used on a website if you're going to actually put it on a website. I'll just create the key. There we go. Now I can see this. Now you're going to need to create one of these yourself. If you try to use the key that you see here in this course, it's not going to work because this key will be gone once we're done. You're just going to follow the same procedure to get your key. So I'm copying this giant string, and I'll be using this later. Now keep in mind, most APIs require keys like this and place limits on how much you can use them before you need to start paying some money. The limits are generally quite generous, so when you're learning, it would be almost impossible to run into them. But just be aware, when using these free APIs on things like websites live on the internet, it could result in maps eventually not working, at least for a time. In any case, we have our key. So let's go back to the code, and we'll start making some changes. First of all, I'm going to scroll down and get rid of that embedded map. Here we are. So I can ditch all of this code. I have a placeholder here for where we're going to put the map eventually, just an empty div for now. We're not using it yet, just keep in mind that it's there. And then in my script file, I'm going to save that API key that I created earlier. I'll set up a little variable called bMapAPI key. I'll paste in my key. Remember, you're going to need to get one of your own. Okay, very good. Now let's visit the documentation and see what we're going to need to do to start working with this stuff. Here's the documentation site for Bing Maps. And we have a couple of things that we're particularly interested in. We have the Getting Started, which tells us about setting up an account and a key. Then we have the Bing Maps Web Control, which is Microsoftese for their JavaScript API for putting maps on our pages. And they also have REST services for things like geocoding, which means converting addresses into latitude and longitude coordinates, routing, meaning directions, static imagery, if you wanted to create maps that are just images, and so forth. What we're interested in is this web control for actually creating maps using JavaScript. It's broken down into various sections here. If we look at this Getting Started section, this talks to us about getting that account and key, which we've already done. So let's look at the next piece, creating a basic map control. First part is just some boilerplate about setting up a page, which we've already done. Now we have some lines about actually including their JavaScript API in our pages via a script tag. This is what we want. And we'll use the SSL version just in case we end up hosting this in a secure environment at some point. It'll work fine either way. So I'm going to copy that script tag and bring it over to my HTML. We'll scroll all the way down to our script tags. Here we go. Here's my custom script. So I want to load that API first. And the format that this is using includes a callback called getMap and a key, which is my maps API key, which I have over here. I just saved it in a variable for my own convenience. I'm going to copy this and follow their example. Just paste it in right here. I feel like I'm just going to rename this callback to initMap. This is just going to be a function that I'll be filling in myself later on. Do we have anything else here? Yes, we need a place to put the map, which we already have in our project, and I've already added a little bit of styling for it to make sure that it'll look nice when it loads. Then finally, we're going to need that function, which they're calling getMap. I've decided I'm going to call it initMap, so we'll add that to our script tag. Function initMap. And I'll add use strict in here, so we're always operating in strict mode. Okay, so far so good. And I'm going to continue following their example code here. Now here at the end is the whole thing. Loading the API via a script tag. Actually, I can see they're calling it their SDK here. And then in that callback function, creating a map. So let's just copy this line and bring it over. And this is an ID. So I need to make sure I'm using the same ID that I have set up here on my site. So I'll scroll up, copy my ID, and paste it in here. We can just save this, then switch over to the browser and try it out. Refresh this. And there we go. We have a map. There's no configuration on this map, so it seems to just be guessing where it thinks I am and displaying that way. I know I'm going to want this map to display a different location, specifically the store, when it first loads. So let's look at the documentation and see if we can come up with something that might help with that before we finish. Looking over here in the Getting Started area, I can see there is indeed a Customize Map options on load. That's just what we want. And I can see here that there's a configuration object that I can pass in along with just creating this map. So let me select this configuration object. I'm going to bring that over into my example code. Put it right here. There we go. One interesting thing here is that I can pass in my credentials here as well, instead of, I assume, just passing them in as part of the script tag like I'm doing right now. I'm not going to use this right now, so I'll just comment this out. I think I can leave everything else. We'll just save this and refresh one more time to see what we have. Refresh. Yeah, there we go. Now this map is configured to show the center of London, and it's using an aerial map, which other places might call a satellite map. Now we are cooking with gas. We have a map displaying, created entirely with the Bing Maps JavaScript API. It's not displaying exactly what or how we want to just yet, but that's what we'll be addressing next. Instead of displaying London, let's move this map so it displays where the store is actually located at this address. Looking at the code, I can see here in the configuration object that I have a center configuration, which is a location, and it needs latitude and longitude. I don't happen to know what the latitude and longitude is of that address for the store, so we need to look that up. In other words, we need geocoding. There are online services that can do this for us. I'm going to copy the address. Like gpsvisualizer.com offers one. But we're already tied into the Bing Maps API, so why don't we take a look at their REST services page that mentions geocoding. Going to just do an on-page search for geocoding. Here we go. So they're filing that under the locations section. We can take a look at that. Okay, find a location by address. That's perfect. That's just what I want. So let's see what this looks like. This is a RESTful API. So the idea is that I will make a web request that will then return the data that I want based on a set of address values for any country, says this. Okay, so this is the URL that I would be submitting to. And I can look at this and see, oh, wow. Okay, this is looking for a very structured way of doing this, involving lots of different parameters that they've put in curly braces here. I don't think this is exactly what we want. We just want to be able to put the address in and see what comes back. So we'll go back, find a location by point, find a location by query. Here we go. That might do it. Let's see what this URL looks like. I have a structured version and an unstructured version. Just looking at these, different URLs. This one looks like it's just accepting a query as part of the query string, so I think that's what I want. Let's copy that and open a new browser tab. There's a lot going on here. I can see I'm going to need my API key. I'm going to strip out everything else. Make sure I have my address copied. Paste that in. I think this will get URL encoded for me. And now I need my API key as well. Let's go back over to the code. I'll copy that key. Paste that in. Hit return. There we go. This is being formatted very nicely for me by Firefox. And here is the center point with its coordinates, latitude and longitude. So I'm going to copy each of these, bring them over to my code. First, the latitude and then the longitude. We'll save this, switch back over to Firefox, and refresh. There we go. We are now centered on Los Angeles. We're zoomed kind of far out, and we're not using a road map, which is probably a more common way to do this. But we do have the map right where we want it to be. That is good. Let's make one more quick change here. I think I like this idea of sending my credentials as part of the configuration object instead of using them in the script tag. So I'm going to jump all the way down to the bottom of this file with Command down arrow. I'm going to trim my API key out of the script tag. Save. And back in my script tag, I'm going to uncomment this credentials line and pass in my API key here. Save one more time, and I'll switch back to the browser and refresh again. Make sure this still works. Great, it does. Now with this geocoding, we did this by hand by just pasting the URL into a browser tab. But of course, it's possible to consume a REST API like this programmatically through JavaScript, which we'll see later in the course. Now we have a map that is centered in the correct place, and we use the geocoding service provided by Bing. As lovely as the aerial version of this map is, I'd like it to look more like a road map, so customers can see the streets and know better how to get to the store. I'd also like to adjust the zoom level of this map so we're a little closer to the actual location, and make a couple other refinements. To do this, we're going to continue with the sort of study skills portion of coping with APIs, reading the documentation together, but also use the API to help us figure out what the zoom level should be. We'll start out by changing the type of the map. Of course, I can do that here, but I want this to load with the right version set. And looking at my code, it looks like the map type ID is what I need to change. But what's the value that I want to set? We need to read the documentation to find that out. So back here on the Bing documentation site, I could search or try and filter by title over here. But most of the time when you need to look through the configuration for different parts of an API, you're going to want something that's usually called a reference. And I can see there's a map control API reference here. Scrolling down, here's a map type ID. Let's confirm, yeah, map type ID. That's what we want to set. So what we're looking for is probably going to be on that documentation page. So let's try it, map type ID. And here they are, Arial, Canvas Dark, Canvas Light, Bird's Eye, a whole bunch of stuff here. Oh, and Road. Yeah, I think Road is what we're going to want for this version. So I will put Road in here instead, and we'll reload this map. Great. Now we have the roads. The next thing I want to do is configure the zoom just the way I'd like it. So let's see. Zoom in a few levels here. This level looks pretty good to me. But what level is it? We can ask the map to tell us. So I'm going to open up my developer tools and switch to the JavaScript console, clear out all these messages. Now, as I recall, I set a variable for this map called map. So let's see if we can see that here. Indeed, we cannot, because this map is defined inside our initMap function. I need a reference to this in the global namespace so I can play with it in the JavaScript console. So I'm going to move this up here and then reset it to the map inside the initMap function. Now we'll save this, come back here and refresh. I'm going to need to reset my zoom level to where I had it before. I'll just go in a few steps here. We'll try this. Open that console back up again, clear the messages. And now map is in the global namespace, which means that I can start to play with the API from here. If I type a dot, now I can see there's a whole bunch going on here, including a bunch of methods that look useful. And one of them is getZoom. Let's try that. All right, my zoom level is currently 14. So if I want the map to load in the way that I've just configured manually by playing around with those buttons, I can ask the map using its own API to tell me its current configuration, and then set the configuration here so it will load that way by default. Close these tools, reload, and there we are again. Great. Currently, I can also drag this map around, and if I use my scroll wheel, we start to zoom in and out. I'd like to disable both those features just so we stay right where we are and this map is always just loading the store. I'm going to need a little help to do that. I can see here there's a map class and a map options object. The configuration for this map is an object, so I'm going to bet that that map options reference page is what I want. Yep, I can see credentials, which I'm using already. There's a whole bunch of stuff here, including disable zooming. That disable zooming looks promising, but what I really want to do is disable the scroll wheel version of zooming. So scrolling up here, I can see, ooh, yeah, disable scroll wheel zoom. Perfect. So I'll bring that over here. And I do want to disable the scroll wheel zoom, so I'll set that to true. Now I need to disable dragging on the map. So I'm going to do an on-page search for drag down here in the search bar, and nothing is coming up. Well, I'll go back to that disable section, all those keys that start with disable, and see what we get. Bird's eye, keyboard input, panning. There we go. That is another word for moving the map around. So I think that's what we want. Let's try it. Disable panning, we'll set that to true, and save this again. Switch over to the browser and refresh. There we go. The map no longer moves, and my scroll wheel will scroll the page instead of the map, but I can still zoom in a little closer if I want to, or a little further away if I want to. So I'm still maintaining some usability of this map and the ability of my customers to figure out where, in context, my store is. So we've got this map pretty well dialed in. We can't actually see the store on here, so we're going to deal with that next. While the map is centered on our store, it would still be nice to have a visual indicator right on that map showing the store. Let's figure out how to do that with Bing's tools. Looking over here at the documentation, I can see that we have something called the map control concepts. This sounds a lot like terminology, which I think is what we need now. We need to know what Bing calls those little indicators on the map. Pushpins looks promising. Let's take a look at that. Yeah, map icons or markers. Great. This is just what we want. Let's try the first example. This looks an awful lot like what we have already. Right here is where the custom pushpin is created. So we're going to just copy this example code right here. Bring it over and give it a try. Our map is defined up here, and now we're going to define this pin. We're using the Microsoft.maps.pushpin class here, and they are putting their pin right in the center of the map, which we could also do. I'm going to take this center point out. I'm going to set it to a variable called store location. Store location is that Microsoft Maps location, and we're centering the map on that. And then I'm going to create this pushpin at that location. Now, this is not Microsoft City Center. This is H+ Sport in Hollywood. There's a subtitle also, so we might as well use that. We'll say this is actually Capitol Records, just so there's no confusion. And the text, I don't know what that is. Let's look back at the example. Ah, I see. There's a 1 here showing right there. We'll use an H for this. So the pin is created, and then there's a second function here, map.entities.push. we are using the name map. We'll double check that this is the same thing in their example code, and it is. So this is just the way that they refer to adding a pushpin to the map. We can do that. Let's save this script and go back and refresh. Okay, that looks pretty good. I wonder what this would look like maybe without that text in there. Let's try that. Maybe we can take this text out of here, save, and try it again. Okay, it's just a dot now. I think that looks better. So now using this pushpin function, we have a very nice indicator on the map showing our customers exactly where the store is. We can enhance this a little more coming up next. If there's one thing that I've learned in my years as a web designer, developer, and human being, I suppose, it's that people aren't always good at reading the details. Now that we've added this map to the page, I could expect people to miss this address that appears right above it. Let's add the address to the map so when someone clicks on this little pushpin, the address appears, so we can stand a better chance of our customers actually seeing it. We're going to need to look at the documentation again to see how to do that. So starting back here on the documentation, I'm going to look under the terminology or concepts area again. And then right under pushpins is info boxes. That sounds pretty promising. Let's take a look at that. Sometimes referred to as an info window or pop-up. Yep, that's what we want. This is often used to display information linked to a location after clicking on a pushpin. Perfect. So we have a basic info box and various other versions, but I can see here info box when pushpin is clicked. Great. Okay, there's a little bit more code here, but let's read through this. First, there's an info box that's defined and set to be not visible. It's added to the map, and then they're generating some random locations here, setting some metadata that goes with the pushpin, and then there's a click handler added to the pushpin, which is down here. Okay, so we just need a few pieces here. I'm just going to copy the example code, just like we've been doing. I'll start by copying this bit that defines the info box. Switching back to my code, they are defining the map first and then the info box. So let's do that. Here is our info box. Creating a new info box. They're putting it at the center of the map and setting it to not visible. Okay, I'll just follow that example. And then setting the info box to appear on that map. Okay, that looks good so far. We don't need a random location. We already have a pin, but we don't have anything about pin metadata. Let's take that over to our code. We need the pin first before we can set the metadata, I assume. And let's set this title and description to the same thing that we have up here. H+ Sport in Hollywood, only this time we'll put the address in the description. So I'll switch back over to my browser and grab it from here. I'll copy that, come back over to my editor and paste it in. Whoa, okay, so that added a bunch of line breaks and things, which is not going to work with a string in JavaScript. We'll set it like this. So we have our pin metadata, and following the example code, what comes next? We need that click event handler. All right, I will add that, pushpin clicked, and we can copy the definition of this function. I'm just going to paste it here right into that event handler. And I can see that what we're doing here is we're setting the options on that info box. And the target of this event is the pushpin, I think, that was clicked. So I'm using e.target. This is pretty common event handling stuff here, where we retrieve the target, that is the thing that was clicked, and then we get its location. Then we get the title and the description out of its metadata, which we set up here, and we set its visibility to true. Okay, I think this is going to work just like it is. So let's save this. We'll switch back over to Firefox and give it a try. Now if I click this, there we go. We have the name and the address. This looks pretty good. I'm curious about one thing though. I wonder if this supports HTML. So we could break that address up onto 2 lines. Let's try that. Just put a little line break tag in here. Save again. I'll refresh. Yes, indeed. Because this name is so long, I think I might actually like it a little better on 1 line. So we'll leave it just like it was before. But that's good to know that we could put HTML in that description if we wanted to. If we were going to have a big info box with a lot of description of whatever the item is that the pushpin refers to, we could do that there. So refresh one more time and see what it looks like now that we're finished. Looks good. Using the Bing Maps info box, we now have a map looking and behaving in a visually pleasing and highly usable manner. We've increased the chances that our customers will actually see the address without being totally overbearing about it. Looks good. H+ Sport is growing. They have a new location right here. For this challenge, we're going to update the map to include that new location. So we're calling this challenge New Location. The address for the new location is 1000 Vin Scully Avenue, Los Angeles, California, 90012. This is really Dodger Stadium. You can use the location's geocoder service from the Bing Maps API to get the coordinates. We're going to need to add a pushpin for this location and maybe an info window. I'm going to leave that to you to decide if you need to add a new one or not. The click event handler we can definitely reuse. I'll give you that hint. We also need to recenter and zoom the map to make sure that both locations are easily visible. You can use your JavaScript console to get the values you need for where the new center point will be and what that new zoom level should be. This challenge should take about 5 or 10 minutes to complete. Good luck! Let's explore one possible solution to this challenge. Scrolling down to the map, I can see here's the Hollywood location and the one that I'm calling the Chavez Ravine location. I lived in Los Angeles, so I know that's what that area is called. It pops up with that info box. It's working like we expect it to. So, how did we put this together? First of all, I needed to geocode that address using the same service that we used before, feeding in that address here and pulling out the coordinates. Back over here in my script, I now have 3 locations up here at the top. I have the store location for the Hollywood location, which I've renamed to avoid confusion here. The one at Chavez Ravine, where I've plugged in those coordinates. And then the new center point, which is not either of those locations, because I needed a place that could show both of them. We've changed around the zoom level here to account for showing both of them at once. I have my info box, which I'm reusing. If we wanted to be able to show both of the info boxes for both locations at the same time, we could have 2 instances of an info box, but because I'm only toggling, I'm just reusing the same one. So none of this code needed to change. I'm setting up the pin for the Hollywood location here, and the pin for the Chavez Ravine location down here. And when I said that we could reuse the same event handler, we did copy it into this add event handler listener the first time, but now that we're reusing it, we took it back out. It's right down here. The definition is exactly the same. It's generic because it's using that event parameter to retrieve the pin using event.target, and then pulling the title and the description, which is unique for each pin. So we can have one event handler that handles either type. And after that, we just have a pin defined exactly the same way as for the Hollywood location for this new Chavez Ravine location. And when I was trying to set that new center point, there were a couple of things that I needed to do in the JavaScript console. First of all, I needed to re-enable panning. Now, of course, I could go back to my map definition and change it right here in the code, but that would involve reloading, and who has the time for that? So instead, I looked over in the map documentation. And just like there are all those getters for different things like getting the zoom and the map type and all that, there are also some setters here, like set options. That lets me dynamically set the options that are applying to the map as it's currently loaded. So what I did was I opened up my JavaScript console, loaded up my map, and called set options. And according to the documentation, it accepts an object of those map options. So I tried setting, here in the console, disable panning back to false. Now if I hit return, I can drag this around again. But if I refresh, it would be reset to my original options. So I was able to drag that around and then use map get center, which returns an object with the latitude and longitude. Likewise, get zoom returns that zoom. So with that all done, I can refresh. We're back to a map that doesn't drag around anymore, and we're done. We have a completed map that shows both of the locations. In this final mini project, we're going to work on this checkout page for H+ Sport. Have you ever noticed how many checkout pages require us to enter the city, the state, and the zip, or postal code? This always drives me just slightly nuts, because if I know that postal code, I can look up the city and state from it, and save customers a few keystrokes. We're going to fix this form so it queries an API for the city and state and fills in those fields for us. There's a simple-to-use commercial service that offers a RESTful API to help with this. This is where I first heard about this kind of functionality for programming. It's called Ziptastic, and if you're going to do this professionally, check them out. You could even use them now if you'd like. The service is called the Forward Geocoding API. Version 3 is their commercial version, but they still have their free version, version 2, available as of the time I'm recording this. If you make a call to version 2 and pass in a zip code, you get back these kind of answers that we'll be using later. But to save you from having to read any more documentation, there's a little API included in the exercise files for this course, but you'll need a local web server to run it. And in general, when working with web requests in JavaScript, a web server is kind of a must. Trying to use third-party services from a file URL, as we're doing here, is not possible in any web browser due to the security features they all have. I'm using MAMP, which is available for free for macOS and Windows. There's also a pro version that you could pay for. There's also XAMPP, available for Windows, Linux, and macOS, and various other options as well. For more information on local web servers, you can look at the course Installing Apache, MySQL, and PHP. Basically, what we need for our purposes is just to be able to have a web server that can run PHP to run our little API file. We do not need any databases for this. I've copied the exercise files from my desktop into the MAMP folder from which the web server does its work. By default for MAMP, that's the htdocs folder inside MAMP's application folder. I've also renamed the exercise files from exercise files to just X files, so there's no space in the URL. With that done, I just open up the MAMP control panel, started the web servers using the button that previously said start and now says stop. And with that, I can load the API. I can also load the exercise files right off my web server. This starts out at localhost port 8888 and then following the path down to the exercise files. This is our work in progress folder, and this is the API. It looks like this. It's in chapter 6, API index.php, and then we pass in a query parameter of zip with a zip code of some kind for a United States city. I'm using 91601 here, North Hollywood in California. And as you can see, the answers that Ziptastic and the version that we're using are quite similarly structured. So we could use either one for these examples. MAMP uses this funky 8888 port, which your web server might not use. And certainly it's not used on the internet. So we'll change this in the MAMP preferences just to try and keep everybody synced up. Over here in MAMP, I'm going to open its preferences. And here in the ports tab, I'm going to change this to the default ports. MAMP even provides a button for this. 80 and 80 for its web servers and MySQL if we cared about the database. For now, we do not. Now MAMP is going to reload itself. You might have to enter your administrative password to make this work. There we go. It loads up its start page and there's no port here. So I'll close this, switch back over to my browser, and I'm going to peel off the port. Just confirm that this still works, and it does. Same with the exercise files over here. So with that port reconfigured, we're ready. Our setup is done. We've seen the API that we'll be working with, and we're ready to start solving this problem. To get started in our keystroke and pain reduction project here, let's think of what we want to do. We want people to only need to enter the zip code, not the city or state. And then when they're finished, query the API for the city and state and fill in those fields. So first, let's hide the fields that we don't want people to fill in as long as JavaScript is available and we can do this at all. Remember progressive enhancement. If this were a real page, we'd want people to be able to fill in all their information and submit it with their order, even if there's no JavaScript. So I have CSS that will hide these fields, and a few others to keep things simple, if we add a class to the body. This is a pretty common pattern in progressive enhancement. Only start to take things away when JavaScript is known to be available and working, using classes to trigger those changes. I'm going to open up the developer tools and go to the console here. So the plan here is to add a class to the body. So I can use document.querySelector to retrieve the body tag. And I can see there's a lot of classes on here. So if I want to update the class, I could use class name. And that's going to give me back a whole string of these. If I just set this to the class I want, which is just JS, that's going to blow away all these other ones. That's not what I want. So instead of using class name, I'm going to use a slightly newer version of how to manipulate classes called class list. This is an element that has a couple of methods on it, add and remove. I want to add the JS class. And so when I do this, a whole bunch of the fields disappear to reduce distraction. I've removed some extra fields just to avoid distraction for our purposes in this project. You wouldn't necessarily want to do this except for the city and state field in a real situation. We're also going to want to trigger our postal code lookup when someone is done entering their postal code here. We could listen to the input, key up, or key down events that all relate to typing in text fields, but that would mean we're firing an event more often than we need to. When the user is done entering their postal code, they're going to move on to other fields, and that field won't be focused anymore. In terms of the DOM API, that is called a blur event, so we'll use that instead. All right, let's go to the editor and write some code. I'll copy this before we go. Close the developer tools. Now here we are in Visual Studio Code. Remember that we're using the copy of the files that's being served by that web server, not on my desktop. So the first thing that we're going to do, I have a few lines in here to just help us avoid a little bit of typing, just some selectors to get the zip code field, city, and state. First thing that we'll do up at the top here is paste in the addition of that class to the body field. And then the next thing we said we were going to do is add a blur event to that zip code field. So this is called zip field here. So we'll add an event listener to that. And this is called blur. And this is going to be a function. You can leave these anonymous or you can name them. I'm going to call this query postal code. And we're going to need to retrieve the value of the zip code field. So that'll be zipfield.value. And we should sanitize this. So let's set a variable, call it zip code. And we'll run this through parseInt because the zip code that we're looking for is just the 5-digit version of it. So we can sanitize it down to an integer, passing in the radix of 10 to parseInt, the same way we've seen before. And if the zip code is less than or equal to 0, that obviously wouldn't be right. Or if the zip code is greater than 5-digit number that's all 9s, we'll return. I'll put a placeholder in here for actually making the query. Once that query is made, which we'll be handling later, we know we're going to want to reset the city and state fields so they're visible, with their values magically filled in. The CSS that we have targets some container of these fields, not the actual fields themselves. So let's figure out how to address those and make them appear again. I'm going to save this file and go back out to the browser. Open up those developer tools again, and we'll get the web inspector. Going to inspect this postal code field. Here are the hidden fields. How far down do we have to go to get to the text fields inside? There we go. So in my code, I'm selecting the city field and the state field, which are these billing city and billing state input fields inside. So we have to go up 1, 2 levels to get to the element that is actually being hidden. So let's experiment in the console here. So here in the console, we're going to play with that city field. I'll just copy this selector, switch back to the browser, and paste this in. Now we have that field to play with. So if we were to just set the style of the city field directly, using the style property and then the display property inside that style property, and setting that instead of none, which hides it, to block. That does not do anything right now. We need to go up to that parent. That was 2 levels up, 2 levels up. We can get to that by traversing up to the parent node and one more parent node. This is a part of the DOM API that will do traversal through the tree, through the outline. So we go up to the parent and then its parent and set its style to block. And now we have that city field back. Okay, so let's copy that and bring it back in here. We're going to need this for both the city and the state. I'll save this and we'll switch back to the browser and check the behavior that we have so far. I have a zip code field, and then when I use the tab key to unfocus that, the town and the state appear. Now, of course, we're only going to want to do this after we make our request and have data to put in those fields. But this is a good start. We've scaffolded out our structure, added the enhancements we need for display and the event handling that we want, and we're ready to make the actual query and use it. We'll do that next. Now it's time to query our API for the postal code and act upon the result. To do this, we're going to employ a JavaScript library that makes HTTP requests much easier to make and handle, and of course, use the data it returns. The library we'll be using is called Axios. It makes working with RESTful APIs, that means APIs that you interact with through regular web requests, much more pleasant. It's a small and focused library, and I use it a lot. It's already added to the index.html file for this project. Let's just jump all the way down to the bottom. As you can see, here it is. It's installed in the lib folder for this chapter. If you're following along in an older browser and the example doesn't seem to work, you might need this ES6 promise file, which fills in missing features of certain browsers. Libraries that do that are called polyfills. You can just uncomment this to use it. Let's take a look at the documentation for Axios to see how we're going to make that request to the API. What we're going to be doing is an HTTP GET. That's what it's like when you just make a regular request in a URL, like this one. And they have some example code here. So it's axios.get, and then the URL that you want to query. And here we have then, catch, and finally. Requests like this can take time, so you don't want to lock up your pages waiting for them. To keep the page responsive, we want to make a request like this asynchronously. If you've heard of AJAX before, the first A stands for asynchronous. We handle the data as soon as it's available, or an error happens, but let the page keep working in the meantime. This pattern that Axios is following here is the JavaScript promise API to handle asynchronous requests, which means that we can chain on these methods like then and catch to handle the initial request and any errors that come up. It's nicely readable and it performs well. So let's copy all of this. We'll bring it over to our script file. Here where I'm supposed to be making the query, I'll paste this in. Now, of course, we want to be querying our API. It's actually on the same server, so I can address it as /API, and then pass in that zip code, which is up here. And here we have the then method, which is going to fire when that request is successful. So we're going to log out that response. Might as well just let it do that, and we'll see what happens. We also have an error handler down here that I hope we just won't need. Okay, we'll save that, switch back to the browser, and try it. I'll fill in another zip code here. Let's try 10023. And I'll open up my console to see what I got back. So I have a configuration object here. My zip is kind of strangely formatted, so I'll bet this didn't work. Yep, postal code invalid. Let's double check how we phrase this. Yep, that should be zip equals that zip code. So we'll save that, refresh. My zip code is still filled in, so I'll just let that blur event fire. There we go. Now we have some data to work with. So inside this response object that comes back from Axios, it has a data property, which is the actual returned data. So I'm going to use this to pull out the city and the state. So the state that we want is the abbreviation, I believe. Let's inspect this element just to make sure. Look at these states, and yep, here all the values are those abbreviations. So we'll use abbreviation for the state, and for the city, the key is probably just called city. Let's look again. Here in the console, yes, city. So we're going to have those values, and once we have successfully gotten those values, we'll want to show these fields and also set the values of those fields to the city and the state. So we'll say the city field value should be this city, and the state field should be that returned state. We'll save this and come on back. Refresh one more time. And there we go. It's working. We'll try a different zip code, 91601, North Hollywood, California. We've done it. We now allow our users to simply enter their postal code instead of having to type in all three of those fields. It's a small detail, but every few keystrokes you can save your users or customers are, in aggregate, much appreciated. We've covered a lot here, but of course there's always more to learn. Personally, I find that exciting, and I'm always looking forward to what I'll learn next. Here are some possible next steps beyond this course. First up, a few courses about JavaScript and other tools. There's my own Learning the JavaScript Language, which is intended to help you become conversant in JavaScript in a way that's kind of application agnostic, just going through what you'll need to know when you're working with JavaScript on an everyday basis. JavaScript Essential Training will take you through just about everything you need to know, both in terms of some of the syntax and actual usage. It's a long course, but will take you a long way. Learning JavaScript Debugging is a course of mine that takes you through using the stepwise debugger built into all browsers' web developer tools. With that, you can stop code while it's executing and really dig in to find out why something isn't working, or why it's working how it does. If you write very much JavaScript, it's a very, very helpful skill to learn. Workflow tools for web development will take you through some of the same tools we used in this course, like the browser developer tools and text editors, as well as many other useful goodies that can help you as a web designer or developer. Here are a few other courses with JavaScript frameworks and other technology that are good friends with JavaScript. CSS Essential Training will help take you further in your CSS knowledge. CSS is quite powerful and can be quite complex, but it's so important to our work as web designers. Interactive animations with CSS and JavaScript will show you how to combine those technologies, as well as SVG graphics, to make smooth, beautiful, and performant animations on the web. React for web designers and Vue.js for web designers are both project-based courses like this one, with a focus on those two very popular frameworks. You can use either one of them to build entire sites, or just focus on one piece of a website. I like and use both of them. Maybe you will too. And finally, WordPress building child themes. WordPress is quite a popular way to make a website, and being able to create your own themes brings a lot of power. Child themes are a great entry point since you can base your work on someone else's, only modifying the parts you want to change. Thank you for watching.